As a data analyst, you are embarking on an exciting journey. Every day, organizations generate massive amounts of data, from transactional data in databases, Excel spreadsheets, to telemetry data from services and messages from social media feeds. But here's the catch. Businesses often struggle to use their data effectively. And that's where you come in. By unlocking the power of data, you can help drive better business decisions and gain a competitive edge. The key here is to tell a compelling story with data, usually through insightful reports. Before the data can be used to tell a story, it must first be run through a process that makes it usable in the story. That's where data analysis comes in. It's the process of identifying, cleaning, transforming, and modeling data to discover meaningful and useful information. And it's not just about the story itself, but where it's told. By sharing your insights with the right people, you can help build a data-driven culture within your organization who can help drive actions from insights. This first section will dive into the functions of a data analyst and the different methods we can create our story with, and share that with our colleagues, members of our organization, and beyond. Are you ready to take on the challenge? I thought you would. Let's dive in. Data analysis is a critical aspect of all organizations to determine the impact on their business, including customer sentiment, market and product research, identifying trends, or any other data insights. In this video, we're going to describe the different types of analytics and tasks of a data analyst. To analyze data, core components of analytics are divided into the following categories: descriptive, diagnostic, predictive, prescriptive, and cognitive analytics. Descriptive analytics helps answer questions about what has happened based on historical data. Descriptive analytic techniques summarize large semantic models to describe outcomes to our stakeholders. It's an excellent way to understand the past and where you are now from a dataset perspective. Diagnostic analytic techniques supplement more basic descriptive analytics. They take the findings from descriptive analytics and dig deeper to find the cause. The performance indicators are further investigated to discover why they got better or worse. Predictive analytic techniques use historical data to identify trends and determine if they're likely to reoccur. Predictive analytical tools provide valuable insight into what may happen in the future. This technique is particularly useful in forecasting sales and anticipating customer behavior. Prescriptive analytics is the next step in data analysis. By using insights from predictive analytics, data-driven decisions can be made. This technique allows businesses to make informed decisions in the face of uncertainty. We can simulate what happens if we play around with changing the price and see that effect on the sales. It's an excellent way to predict the future and make decisions based on those predictions. And finally, cognitive analytics. It helps you learn what might happen if circumstances change and how you might handle these situations. It derives conclusions based on existing knowledge bases and then adds these findings back into that knowledge base for future inference, creating a self-learning feedback loop. As we build layer upon layer, we start to find pockets of values to them, although each layer increases the complexity in achieving that task. These different types of analytics can help you shape a story. Descriptive analytics can identify a problem. Diagnostic analytics can find the root cause. Predictive analytics can estimate the impact. Prescriptive analytics can recommend a solution. And cognitive analytics allows you to learn from your approaches. By breaking down the analytics progression means that we can evaluate how different types of analytics can help answer different kinds of questions and support decision-making. Ultimately, they answer what? What do I want to achieve to support me in my storytelling? And as an analyst, knowing that you can build upon each of these components helps drive you towards reaching a dataset's potential. By harnessing the power of descriptive, diagnostic, predictive, prescriptive, and cognitive analytics, you can turn raw data into meaningful insights that inform decision-making and help businesses make informed decisions that drive success. We're not going to do all the categories of analyses overnight. It takes time to iteratively build upon them because each layer adds more complexity and hopefully more questions compared to the previous layer. Take some time to reflect on what your organization is currently working on now. Where do you sit in this problem? What analytical problems have you been asked to work on? We're going to detail the tasks of a data analyst. Before data can be used to tell a story, it must first be run through a process that makes it usable in the story. That's where it's vital that you understand the tasks that are performed on a near daily basis. What you see in front of you is the process of identifying, cleaning, transforming, modeling data, and then applying that in analytical approaches discussed previously to discover meaningful and useful information. As a data analyst, you play a crucial role in uncovering valuable insights for your organization. And to do this effectively, you'll need to perform 5 key tasks regularly. The first task is to prepare the data for analysis. Bad or incorrect data can have a significant impact on the accuracy of your reports, and this leads to incorrect decisions and negative business impacts. So, you'll need to make sure that the data is in good shape through cleaning and transforming the data before moving on to the next step. Once the data is prepared, the modeling task comes next. In this task, you'll determine how your tables are related to each other, defining and creating relationships between them. You'll enhance the model by defining metrics and adding custom calculations to enrich your data. The third task is to visualize the data. This is where you get to bring the data to life, creating compelling and impactful reports that tell a story and enable decision makers to gain needed insights. Using appropriate visualizations and interactions, you'll guide that reader through the content quickly and efficiently, allowing them to follow a narrative into the data. The fourth task is to analyze the data. Here, you'll use the analytical capabilities of Power BI to find insights, identify patterns and trends, predict outcomes, and communicate those insights in a way that everyone can understand. Finally, you'll manage the Power BI components, including reports, dashboards, workspaces, and semantic models. As a data analyst, you'll oversee the sharing and distribution of these items and ensure their security. Let's zoom out so we see the whole picture in front of us. First, we prepare, then we model, then visualize, then analyze, and lastly, manage our process. As a data analyst, you play a crucial role in unlocking the power of data for your organization. By regularly performing the 5 key tasks of data preparation, modeling, visualization, analysis, and management, you can deliver accurate and impactful reports that drive informed decision-making. Before I go, I have a request. Take a data set in your organization now. What do you know about it? Where could it fit in your story? What kinds of analytics can you perform on it? Power BI's framework consists of a collection of software services, apps, and connectors that all work together to provide you with a seamless experience. Let's break down the different types of tools that you will encounter as you begin to work with Power BI. There are different ways in which you can interact with Power BI, which depends on if you're a creator, a viewer, or an administrator. We will dive into the Power BI desktop service, as well as the mobile. The first component of Power BI is the desktop, a free application that you can install on your local computer. It allows you to connect, build your models, transform, and visualize your data in a way that is easy to understand. Inside of the Power BI desktop environment, you also have the Power Query Editor, which is an engine that supports you in preparing, cleaning, and transforming your data. It opens up a separate window every time you need to work with it. The second component is the service, and I refer to it as the Power BI web. It's a software as a service platform that brings together our project-specific workspaces, reports, dashboards, semantic models, and more that are distributed out at enterprise scale. It provides you with a comprehensive view of who is interacting with your reports, as well as your dashboards, and how your organizations are utilizing them. So you can keep your finger on the pulse of what's happening. And finally, there's the mobile component, which allows you to connect to and interact with your cloud, as well as on-premise data on the go, for when you need to sync your data, even to a tablet. And this can be done in your Power BI desktop environment under the View tab or Service environment under the Report tab. I've spoken quite a few jargony words here, like workspace, reports, semantic models, and dashboard. So let's just take a moment to make sure that we are on the same page. When we're inside of our Power BI desktop environment, we will connect to our data. And when we connect to multiple data sources, it becomes a data set. And when we use this data set to start building connections, relationships, and enhancements between the data, we call this models. This is where you start to present the data into collections of graphics, texts, and visualizations. And these visualizations can be customized to show the data in a way that's easy to understand. The entire collection is referred to as a report. And a report is a collection of visualizations that appear together on one or more pages. When we share and distribute to the appropriate audience, like our senior leadership team or colleagues, we publish the reports. Our data sets in our enterprise environment become semantic models. This includes all of the changes we've been doing whilst building our story from the preparation to the analysis, like creating measures as well as calculations. If we know it's going to be distributed out to a large number of individuals, we'll create an app, which is a read-only report. But if we know the intent is to get quick insights into the data landscape, we could use a dashboard. Dashboards combine a collection of visuals from a variety of reports into a singular overview. Pretty cool. And yes, these can be shared out, although it's recommended as a place to provide a summary or overview. So let's conclude. Microsoft Power BI is a collection of software services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually immersive, and interactive insights. We touched on a few building blocks like Power BI Desktop, Power Query, semantic models, reports, dashboards, and more. And if you would need a little bit of a reminder, remember that you can jump into the documentation or ask a large language model like Bing Copilot to just check your understanding. Let's discuss a high-level overview as to how a data analyst uses Power BI. There are 5 tasks a data analyst will do, and we're going to label this as 1, 2, 3, 4, and 5. These are prepare, model, visualize, analyze, and manage. The activities and analyses that you'll learn with Power BI generally follow a common flow. And the common flow of activity looks like this. In Power BI, tasks 1 to 4 are done inside of the Power BI desktop. And to summarize, we are going to be capturing the data from a variety of sources. We're also going to be transforming and cleaning, combining data sets together, preparing the data, building relationships between the data sets, writing calculations, designing and creating the report, as well as all of the other fun stuff. Combined, this will take about 80 to 85% of your time because you're designing the report in a way that's not only for you, but for others, and sometimes less technically savvy others. A lot of thought often goes into this stage. In Power BI Desktop, you publish the report. Just make sure that you're signed into a suitable account. And when you're ready, you share it as a link or invite specific users to view your report to those who need it. A published report leads you to the next section, where you're ensuring that the content can be distributed out. You need to make sure that you have the correct licenses, as a free license no longer can proceed to this next step. And in this next step, step 5, you need to start thinking about maintaining the report. We often have a vision of how a user will utilize the findings, and sometimes this vision isn't always right. So then we can go back and tweak and refine our report. We can identify which graphs make the most sense to be shown first, make changes, and also enhance the report a second or third time around. If we want to use all capabilities of Power BI, we can then start to think about how we relay this further using our smartphones or have it viewed across a fixed monitor or tablet device. All of these reports and dashboards are available in the Power BI mobile apps, whether they're on-premise or in the cloud. So, let's summarize. You bring data into Power BI Desktop and create a report. You publish that report to the Power BI service. Then you transform your reports to create dashboards and apps, which allow you to easily share your content. You then distribute those reports, dashboards, and apps to the appropriate target audience and let them gain the benefit on their preferred devices. How you will use Power BI will depend on your role, on a project, or within a team. And users with other roles may use it differently. And that's the beauty of Power BI. It's a flexible tool that can be tailored to your specific needs. Let's take a tour of the Power BI desktop application. So I'm inside of a Power BI environment and I have loaded a report onto my screen. Now, the first thing I want to draw your attention to is that we are immediately presented with visuals because I've already pre-built this report for you. And what you will find is that I have at the top here a bit of a ribbon chart, and what this ribbon chart represents is that I can draw little buttons and I can interact with the buttons from a high level overview. So I can navigate through these. That's the first thing I want to draw your attention to. The second thing I want to draw your attention to is the fact that I can set up a mobile layout. And inside of this mobile layout is that I can play around with how a user will see the screen. The next thing I'd like to point out is, let me just minimize this one more time, is that I can actually navigate through my reports. So if I click on these pages, I can find the various kinds of images and collections of visuals that I want to tell in my storytelling. I can also create pages of reports that I have available to me. On the right-hand side, you will find that based on how your Power BI environment is installed, there will be different things you can interact with. So as you can see here, I have my data loaded because I clicked on this specific icon. But if you have the option, you can always just add a few more. This is the report view. If I hold onto this little icon, these icons will allow you to navigate and play around with different aspects of Power BI. Of course, the report is one of the final and most important elements of data analysis, but there's also the preparation stages and the ability to identify the different kinds of data. So the second icon is this tool called the table view, which shows the different kinds of data that you have, where you can explore the different environments of your data sets, potentially see if you need to create new columns with the data set or new tables. Also in this situation, note that it also comes with a ribbon tool and it changes. So we need to be aware of how we get our data how this data gets translated across, and it will depend on the type of storage modes. Lastly, we have the model view. And in the model view, this is how you can acquire, bring in your data, and build your semantic models. So for instance, here you can see that there are the data sets that I pointed out in the previous tab, but now we can start looking at how the relationships unfold, which we'll jump into at a later point. Inside of this model, we can actually derive that there are 8 tables available to us, and they're all centrally connected to this main table. That's what I can immediately draw. Data. What I want to draw your attention to is that there are these little abilities to require this Get Data kind of tab and draw in a variety of tools. When you work with, you want to start thinking about transformations or pre-processing steps, what you will want to work with is this transform data. You simply just need to click it and it will open up a separate tool, which we will jump into in a later video. The last thing I'd like to pull your attention to is that inside of your environment, your Power BI environment may look different depending on the versions that you'll be working with. But one thing that's very common across all of them is that inside of the file view, you will have the ability to set up your settings in a way that makes sense to you. So I am jumping to this Options and Settings tab here, and I'm clicking on this Options. And the reason I want to do this is I want to just share some of the things that you can do inside of Power BI that might be a good first step, especially if you're joining me on this video to try things out. So in the settings, you will find that there are different kinds of things. So in the current file, which is the current Power BI file, the report that you're seeing with all of the components, I can be in control of how the data loads. So you will notice that there are a lot of default settings that are turned on and also that can be configured to your specific use case. When it comes to importing your data, you can then think about how the data gets translated across. You can see if you want to use specific visualizations and tools, but I also want to point out a little bit of the importation mode. So for instance, if you're importing your data, you may need to, and you're working with, for instance, data from different companies, you will want to potentially set the regions so it translates the right approach. So for instance, commas being translated into full stops or vice versa. In the global side of things, one thing I'd like to draw your attention to is the preview features. And these are the latest features that are currently being tested by the Power BI team. And I recommend just playing around with this, seeing what works for you, experiment a little bit. That's what I would like you to do in this first situation. But just note that there are a lot of things that you can play around with. So current file represents the specific report. Global applies to all of your Power BI reports. And there you have it, an example that explores Power BI from the beginning. We covered the ribbon tools and different options that you can find in your settings, along with the different kinds of views Power BI Desktop provides you. Now, the first thing I want you to do now is explore the settings. I want you to start taking a closer look into the different kinds of options you have available and start configuring your Power BI Desktop in a way that works for you. Learn anytime, anywhere. I'll see you soon. If you've worked with data before, you will know that it comes in different shapes, sizes, and formats. Sometimes it's given to you and the experience is smooth sailing. You lucky duckies, you. Other times it's an absolute horror show and you know you're going to have to roll up your sleeves and get your hands dirty. Power BI needs to accommodate the ability to support you regardless of how the data comes to you. It doesn't matter if the data is categorical or numerical. You design your blueprint of how you want the final result to look like, irrespective of the type of data, the location, and where it's stored, as well as the size of the data. Building your blueprint is a very visual and interactive experience. And when I talk about blueprints, I am talking about transformations and pre-processing steps. Power BI gives you the freedom to experiment and play around with the data until you get exactly the output that you're looking for. And it does this using the Power Query Editor. This next section will jump into showing you how you can bring your data into your Power BI environment and transform it to meet your needs. As a professional working in a data-driven organization, it's important to know how to build effective Power BI reports. And the first step to that is bringing your data into the Power BI framework. We will explore the basics of connecting to data using the many connectors available. Imagine you're working on a project that requires data from several different sources like Microsoft SQL Server and Excel files. This is where Power BI comes in handy because it allows you to connect to various data repositories irrespective of their location. Connecting to data is easy with Power BI because by default, the data is imported into your Power BI desktop file, leaving the underlying data unaffected. However, there are other storage modes which we'll cover in a later video. Power BI offers different connectors to a wide variety of data sources. It doesn't have to be Microsoft-only products. You can, of course, connect it to other cloud providers coming from Amazon, SAP, Snowflake, Oracle, just to name a few. But you can also connect to your on-premise environments too. These connectors allow you to easily turn your data into these meaningful insights. And the way you can find these connectors is in the Get Data dialog box. It's important to note that certain connectors may require different initial configurations to authenticate that you are allowed to be accessing the data, but they all serve the same purpose of connecting to your data. Now, let's take a closer look at some of the most common connectors that Power BI offers. You'll find connectors for files like CSV and Excel, as well as folders. You can also connect to databases, Power Platform, Azure, and online services, among others. Let me show you 3 short examples where we will connect to a CSV file, a data warehouse, and a Fabric OneLake. So what I would like to do is start off with the CSV file. So the way I would be connecting to the CSV file is I would be navigating to this Get Data tab. When I go into this Get Data tab, I can use an Excel workbook, but you can see here that there is this text and CSV file. The way it works is all you need to do is just find it in your local file. It needs to be installed locally for you to access it. So when I jump into that specific file, let me just click it. I can then open it up and it will present me with the option of, hey, do you want to do any transformations? This is what the data looks like. This is what you need to do with this data. I'm getting a good preview of the data and I can choose to load it directly into a model so it saves as it currently is. Or if I notice that there needs to be some transformations, for instance, in this situation, the column names aren't being corrected, I may want to transform the data instead. I'm just going to load it for now. The second one I wanted to show you is connecting to a data warehouse. And in this example, I will connect to a Synapse data dedicated SQL pool. So the way it works is in here, you don't see that it's available to you. So all I have to do is click this More button. And with this More button, it shows you the variety of services you have available, but I'm only interested in Synapse. So when I click that, I can then connect to a dedicated SQL pool. We're going to go for the standard approach. And what it's asking me is to connect to a specific server. So inside of my portal, all I have to do is retrieve the data that I have for it. So if this, for instance, it's the endpoint name or the location of it. Let me just quickly grab that information. There we go. So you'll notice these little asterisks here require you to insert some form of information here. And I'll have the choice between how I connect to the data and how I'd like to connect to the data itself. Let's use my organization account and just sign in using that. Then all I need to do is just click that next button and it will load the different kinds of data warehouses you have in your specific sign-up service. So here I have my dedicated SQL pool up and loaded, and I can just select a few tables depending on what I want to work with.
And then we have the OneLake Data Hub. And the way you can connect to the OneLake Data Hub is simply by accessing the Data Hub. And if it's not here, don't worry. All you need to do is just check inside of the Get Data ribbon button that you have available to you. So I'm going to connect to a data warehouse and select just any data point that I want. Let's use via a SQL endpoint. And what this will do is it will connect to my Fabric environment. I'm just going to sign myself in. And there you have it, an example of selecting it. Just need to select my tables and load them into view. And I can choose whether it's a direct query or an import of my model. Let's do direct query for now. And if you pay attention to your data side, it will automatically load it from your data and into your model as well. So perfect to get started with.
And there you have it. We provided 3 different examples that connects to different types of data. But as you experienced, check the connectors to see what use case applies to you. As you learn to build Power BI reports, take a moment to reflect on the data sources you're most familiar with. Find 2 data sets within a similar function and add them into your Power BI environment. This will help you understand how to connect to your data and build effective reports. Here's my challenge for you. Take a Wikipedia article and bring it into your Power BI environment. What are some things that you notice? Let's explore what I mean when I talk about storage modes. You may have noticed that when it comes to ingesting data from a cloud environment, especially around the databases, that sometimes you get the option to decide how the data gets brought into Power BI. This is called storage modes. There's a clever engine inbuilt into Power BI that deals with the storage. In the background, this engine can determine whether the data gets stored inside of Power BI or to query from the main data source. To store it inside of Power BI, it's referred to as an import storage mode. To query from the main source is referred to as a direct query storage mode. Whichever one you will use will have various pros and cons to your Power BI report, such as impacting the semantic model size, the availability of data transformations, the availability of accessing the latest data, as well as performance of data retrieval. So what's the difference? Well, I like to use the analogy of going grocery shopping versus ordering takeout. So the task is to gather ingredients to make a meal. Your Power BI fridge is empty. So when you use the import mode, you are going to buy groceries from that store and you bring them home and put them in your fridge. You can use the groceries to cook whatever you want, whenever you want. However, you do need to go back to the store periodically to get fresh groceries, or else they might go bad or you run out. In Power BI, the import mode allows you to work with your data offline and have control of how you want to utilize, model, and transform the data. But it also requires you to use more of your storage space when you publish your reports, as it caches the data. You also need to set up these regular refreshes to make sure you have the latest data available. And what does it mean to refresh the data? Well, it's about updating the data to the latest status. I open my fridge door and check what is in there and take an observation and close it again. When you use direct query mode, you are ordering food from a restaurant. You can choose from a menu of dishes that the restaurant offers, and they will deliver as much food as you need, hot and fresh. However, you need to make an order every time you want food and wait for them to prepare for it and deliver it. You are limited in what you can change, like for instance adding a sauce or topping, but you can't make drastic changes to the data itself or the dish. So direct query allows you to work with large volumes of near real-time data as it's taking data from the source. But it also depends on the availability and performance of that source. You are limited in the types of transformations as well as modeling capabilities when inside of your Power BI environment. The documentation will detail this further. There are other storage modes that play from the storage mode previously discussed. Some other examples include dual storage and direct lake. You can use dual storage mode, which creates a hybrid or composite model. And a composite model combines both import and direct query modes. This is like having some groceries in your fridge and as well as ordering food delivery for when you need to make more space. It's useful for when you need to combine multiple sources of data with different storage modes. You let Power BI determine when it switches from an import to a direct query. But you also need to be careful about the compatibility and consistency of the data because, again, not all transformations and modeling functions are supported when using direct query storage mode. It's also worth mentioning that if you decide to ingest Microsoft Fabric data sources directly, Direct Lake is essentially direct query, where you are taking your data from a lakehouse. And if I added Direct Lake into this analogy, it would be like creating a smart fridge that is able to take the data from the one lake, which is the storage offered in Fabric, and retrieve it directly into your fridge. And this can be a huge game changer for Power BI users who need to work with these large data sets and require real-time data updates. It's the perfect balance between the import and direct query modes. So Power BI determines how to store your data, so you don't have to worry about the technical details. You just choose the mode that works best for you and start building those amazing reports. At later stages, when we start focusing on enterprise scale, we will want to work with optimization, where the solution will provide the fastest performance with the lowest latency. So, which storage mode should you choose? It's going to depend on your specific needs and your license subscription. Import mode is by default recommended as it offers the best query performance, but it is limited based on the semantic model size. However, if you do require these real-time data updates from larger tables, then direct query, dual, or direct lake might be better suited for your needs. To conclude, Power BI storage mode allows you to choose the best way to connect to your data sources, whether it's import mode, which is like grocery shopping and lets you work with your data offline, or direct query mode, which is like ordering food delivery and giving you that real-time data updates. You have options to suit your needs. The dual mode, composite model, and direct lake combine both import and direct query modes, giving you the best of both worlds. There's a lot of documentation surrounding best practices, advice, and tips, and I recommend you start with looking at import storage mode best practices first. Let me start this video off with a story about Alice. Alice was tasked with importing a dataset into Power BI for a critical business report. Little did she know that her data journey would involve mysterious blank columns and error messages. She noticed that the sales amount column was empty, but it was there in her source. Don't panic, Alice. Getting errors is part of the Power BI process. Power BI is a powerful tool for transforming, analyzing, and visualizing data from various sources, but sometimes you may encounter errors while importing data into Power BI. Each data source might have dozens and sometimes hundreds of different error messages. And these errors can be frustrating and confusing, but don't worry, I'm here to help you fix them. Let's unpack some of the errors that you may encounter when reading the data. There's a lot of different error messages that you can get, ranging from access issues, network issues, query timeouts, and schema difficulties, to name a few. It all depends on the source that you're extracting your data from. Although we won't be able to explore most, let's talk about the common data import error messages. Let's start with the first error. The query timeout has expired. This error occurs when you are importing data from a relational data source, such as a SQL server, and the query is taking too long to execute. This can happen for a variety of reasons, ranging from a slow and unstable network connection, organizational policies spanning data import restrictions, or query timeout limits. It could also be that the systems, your source which is hosting the data, is overloaded with other requests and is busy. So often, a first step to troubleshoot to see if it's the source being your major problem is to reduce the data volume and query complexity. You can group and aggregate data and reduce the number of tables you're joining. Working with smaller chunks of partition data can always be joined again in the transformation process. Now, let's look at the second error. We couldn't find any data formatted as a table. This error usually happens when you are importing data from an Excel file and Power BI expects to find the data formatted as a table. A table is a range of cells that has a header row and structured data, and Power BI uses the tables to identify and organize the data that's inside of it. To fix this error, you need to format your data as a table in Excel and just try again. Moving on to the third error, we couldn't find the file. This error occurs when you are importing data from a file, such as a CSV or a JSON file, and Power BI cannot locate the file. It's gone missing. This can happen because of two reasons. The file has moved to a different location, and the file permissions have changed. To fix either one of these errors, you will need to find that file and update the file path location in the source settings in Power BI or through M in your Power Query editor. Finally, let's discuss the fourth error, data type errors. You end up seeing errors in your Power Query editor or blank columns. And this actually sounds a lot like the problem Alice encountered. These errors occur when Power BI failed to interpret the data type of a column correctly. For example, Power BI accidentally treated a text column as a number column or vice versa. And you do have multiple approaches in fixing it. First, you could just drop the column. But in Alice's situation, she needs it. So I would recommend she either replace the error type or change the column type. Sometimes just jumping into Power Query and using the cast function solves quite a few things. So Alice went down the route of using Power Query and she changed the data type and also did a few little transformations while she was at it. Way to go, Alice. If you notice the data is inconsistent inside of the column, for instance, the database entry containing commas and full stops in that same data set, then you should probably resolve that in the source before bringing it into Power BI. It can be fixed in the query editor though, but it will significantly impact performance. These are some of the most common data import errors that you may encounter in Power BI. Of course, there are other types of errors that can arise from the diverse and complex data sources that Power BI supports. So if you encounter an error that is not covered in this lesson, you can search the Microsoft documentation for the error message and then work towards the resolution that you need. Data import errors can be challenging, but they can also be opportunities to learn and improve your skills. Remember, practice makes perfect, and the more you work with data, the more you will master Power BI. Now, it's time for you to apply what you've learned and try to import some data into Power BI. You can use the sample files provided in this course or use your own data sources. Experiment with different queries, data types, and settings and see how Power BI handles them. If you encounter any errors, don't give up, but try to find the root cause and the solution. I believe in you. Learn anytime, anywhere. I'll see you soon. When it comes to transforming your data inside of Power BI, the Power Query Editor becomes a major ally of yours. Let's take a closer look at Power Query Editor. Think to a time where someone has sent you a dataset, and at first glance, it's exactly the data you need to help drive your analysis and narrative. Perfect, you think. And then you come to work with it and it's, this will take 5 minutes, expands to 5 hours of horror, and 2 days later, you're still trying to clean it. Data is messy. It doesn't always come in the way you expect. There's always anomalies somewhere that will need to be addressed. In Power BI, we use the Power Query Editor to help us bring order to the chaos. It's a powerful tool. You can shape, transform, and prepare your imported data to meet your needs. From renaming columns and tables to changing text to numbers, removing rows, and even just setting the first row as a header. This is just a few examples of what you can experiment with. We won't cover all the aspects, but I do suggest exploring them in your own time to know what options are available. So to access the Power Query Editor, you will need to click the Transform button. This can be found in your model view or your report view. I'm currently in my model view, so when I click this Transform Data, I'm just going to select the first option available. And as you can see, a new window opens. In this new window, you will be presented with data that has their own transformations, and the layout will change depending on which Power BI version you use, but in general, the functionalities should remain the same. So on the left-hand side, you will have queries. And when we talk about queries, this is about retrieving the data. So for instance, we can retrieve the data using this get data command from our ribbon panel. Again, please pay attention to the fact that the ribbon inside of Power Query Editor is different from the Power BI desktop. This is what I really want you to explore as you go through your understanding of the Power BI landscape. So with this specific query, you can jump into them and they will show specific tables that you have available to you, right? I can, for instance, create a whole new data set and just say example column, and then just give it just it's just one row of data inside of here. And what you will find is that inside of this query, a whole new data set appears, right? So I can rename this query, I can play around with this query. This is where your data set is lying. Now, I can do a few cool things here. It's a bit of a high-level overview regarding what you can play around with. So we're in the home page that will always apply, and there are little buttons that you can play around with. Again, I encourage you to go through these in your own time. They will be specific to your use case as to when and where you should be using them. But yeah, just navigate through them and spend some time here. So let me show you some examples of working with queries. So I have this Connecticut data set. I took it from the data set which takes the median sale prices from states within the US. And inside of here, I can play around with this data. Like you can see there's this little button here. And if I click this, it will open up other things. Like you can see there's date, median, sales. And if I select OK, you will find that the whole data set suddenly becomes available. So just check firstly if you have data that is embedded in other types of sources. You'll find here that I have data that depends on the type of rows that I have available, as well as the ability to explore my data in greater detail using profiling tools. Now, let me give you some examples. So in this specific data set, I'm going to play around with the median sales price and the date, which means I don't need these other values here. So instead what I can do is if I use the shift key or the control key, I can hold control and click, I can access multiple tables and decide to say, hey, if in the future more data comes into these columns, I can just remove other columns, or I can just choose those specific columns to be selected. And what you will notice is that text appears in the top, which is using the language M to make this specific change. And also on the right-hand side, these query settings appear, and these represent the steps in which you can work with your specific data set. Now, if I wanted to, from this specific removing of tables, I can then rename this specific action. So we removed columns, right? So I can rename it to, for instance, keep date and median, right? And then what I can do is start playing around with the data values. So in this situation, I can see that there's these little buttons here, and this will tell me what kind of data type it's currently at. But if you read the name of the column, which is date, right, I can see that it's actually containing date values. So if I click this, you will see that it's not really being treated correctly. So how can I change that? Well, if I just click that little button, I can actually change it to a date time or just simply a date column. And it will throw me an error. And why this is throwing me an error is because it's not completely formatted to the right date time version. So I can just replace the step. It's very forgiving as a specific tool, and you will find that it will change the data that is needed. Now, I can also change the kind of median, because median sales price, this is something to do with currency. You need to have a little bit of subject experience or domain subject experience to know what your data is working with, but I can change the currency, and again, can change the settings to match the right kind of currency that I want to deal with. But for now, we're just going to stick with the dollar symbol, which is the default value. So when I change the currency and the date, I can then start playing around with the right kinds of variables. So we have the date. I can now, if I right-click this little arrow here on the specific column, I can now start applying more things, more filter kinds of environments. So I can say, hey, I want data that's going to be after, let's say 2001. 2001 seems like a good history value. Let's change the time to January 1st. Seems like a good number to go for. All right. So if I go for this OK button, then my data set will only include data that continues after 2001. So that's an example of creating a transformation. And as I pointed out, every time you apply a transformation, a query gets added into it. And this is basically saying, I want you to do this specific action to the data set. Just note, for instance, though, if I change something downstream, like for instance, right now, if let's say I remove the changing of my date value, let's go for this one, there is the potential that it will create some problem down the line. So just make sure that it will create this kind of knock-on effect, resulting in the editor throwing errors. So this could be due to, for instance, me removing something or me renaming something. But it's no problem. All you need to do is just go back in your previous steps, as an example, and then make the change or figure out what went wrong exactly. So let me just insert this back in, and you will find if I click on the next one, everything's back to normal. So when you're ready to save your transformations and say, okay, this model is now ready to be used, or this data set is now being ready to be worked with within my semantic models, I can basically click this close and apply button. It will load the data set, and then you have a cleaned data set to work with. And there you have it. We provided an example of a few common transformations that you can immediately take with you to your current data sets. We explored Power Query, which is the tool in which you can organize and transform your data. Take some time to familiarize yourself with how to open it from the desktop, and if you have a data set you want to explore, start small by renaming a column for yourself, and keep learning anytime, anywhere. Did you know that there's a simple hack to understand your data descriptives? the Profiler tool might be the right one for you. We're going to learn about the importance of profiling and how it helps you get a more high-level overview of your data. Power BI provides several tools to help you better understand the data that you're bringing into your semantic models. One of these tools is the Profiler tool. It helps you understand your data, leading you to make better decisions during that data preparation stage. What do I mean by better data decisions? Well, data is messy. Often, it is possible to have missing data, inconsistent data types, and errors within the data that can lead to data quality issues. So, what do I mean by to profile one's data? Well, it's a way for us to understand the nuances or metadata of our data by providing column-level statistics. It will allow you to find anomalies, understand your data distribution, and have a more detailed overview into the surroundings of each of your columns more easily. The purpose of data profiling is that you can better understand your data and make better informed data preparation decisions. To use the Profiler tool, you're going to need to be inside of your Power Query editor environment. Then what you'll want to do is click the view, and inside of this view, you will want to navigate to these data views. Again, it may look different depending on your Power BI versions as they update the user interface. You will find the following options that allows us to understand our data. Let me just click this Enable Column Profile. We have the ability to explore our column value distribution. We have the ability to explore our column quality details and the ability to show our column profile within the details pane. And by default, it lets you see the statistics of the columns for the first 1,000 rows. And what I can do is if I click this value, you can see that this value is based off of 1,000 rows, but I already set it to the entire data set. But just be aware that if you do this entire data set, it may take a bit longer to pre-process your data. So first, let me click the column value distribution. So the first thing I'm drawn to is this lovely graphs along each of my individual columns. What do they tell me? Well, I use this to identify the skew of the data. I can identify if there are a lot of categories inside of a column, which often means a high cardinality, or if there's actually a few value points. What you'll also know, if I zoom in a little bit, is that I have this distinct value, and if I make this column just a little bit bigger, I also have the ability to see these unique rows. So the column value distribution feature shows you the difference between a distinct and unique value. So let's dive into a quick definition of distinct versus unique. Distinct values are the number of different values in a column. The unique tells you the number of values that appear only once in that column. Let me give you a more simplified example. I have the following column that contains 5 rows of data. We can see that we have the following letters: A, B, A, C, and D. The distinct values from the groups of numbers are A, B, C, and D. And the unique values are B, C, and D. The reason behind this is that A is appearing twice, so it's no longer unique. Now that you can see that the unique values count only those that occur once, whereas distinct values is the total count of all different values. So in this example, I would have 4 distinct and 3 unique. Let's confirm that in Power BI. The unique values count only those that occur once, whereas distinct values is the different values within that column. So if I put this data set inside of Power BI and run the column distribution profiler, you will see the output of 4 distinct values and 3 unique values. Like the name implies of column distribution, it explains the distribution of data within a column and the counts of distinct and unique values. Let me just turn this off now. And let's take a look at the column quality. Column quality shows you whether the data inside of your columns contains values represented as valid, error, or empty rows. Everything is percentage based. So you can work towards fixing the errors and then at a later stage in your data preparation, determine if and how to address the examples. For instance, in this specific column, I can identify that most of the rows are missing in this specific column. Okay, let's take a look at the next column feature. Let me turn off this quality details and now jump into the column profiling page. At first glance, it doesn't look very special, but let me just show you something cool. I'm going to click this one. And when you click a specific column, what happens is that there is a column profile that appears specifically on that column. If I click another column, what you'll find is another image appears. So let's dive into the statistics behind what is being shown. You are presented with a descriptive of that specific column, which tells you a little bit about the count, the errors, the distinct values, the unique count. It gives you a bit more of a granular view as to how it works. And you can use this to also identify the averages, the mins, the maxes, the ranges, to see if there are any outliers and make an assessment of whether that specific data makes sense. Now, this is an example of a numerical category. Let me give you an example of a string. I'm just going to click this product name. And what you will find is that the column statistics, depending on whether the data type is categorical or numerical, will differ. So, for instance, I no longer am presented with additional numerical data points like the standard deviation or the range or the averages. Instead, what I'm presented with is the distribution. And this can be very useful for identifying changes in the data where you may have overlapping data that has been entered incorrectly or the wrong data entry points. Numerical values can help you see outliers. So we can see a specific category is contributing to the most of our sales. Categorical value. I'm trying to identify what I did here. It's throwing me off a bit. Where did I do this? I feel like I have a different thing and I'm using the wrong one. I think it was the one that was missing. Oh well.
Hold on, so are we taking it from the top there?
Let me go back to where I was at. Yeah.
On 3, 2, 1.
So numerical values can help you see outliers, and we can identify whether a specific element is contributing to a specific output. Categorical values can help you identify potential typos, spelling mistakes, and understand an overall detailed view into the overall data. So as you can see, it goes into detail regarding the different kinds of distribution, the quality of your column, and provides a little bit more of a descriptive analysis to help you identify where to start looking and cleaning into your data transformations. Just note that I can enable all of these to happen at once. Play around with it. And there you have it, an example of working with the data profiling tools. We looked at how we can explore the distribution, the quality, and descriptive analysis per column within your datasets. In summary, we want to be using data profiling tools because they allow us to get a high-level overview of what we're working with at a columnar level. It can help us understand new data and also investigate any existing data changes so we can react accordingly. It's a very useful first step in your pre-processing stages, especially when it comes to creating high-quality data that in turn creates high quality reports. And in turn, that brings impact. Definitely take some time to explore this in your Power BI environment, especially when you're working with new data for the first time. In this video, I'm going to show you an example of how I would be using Power BI to clean, transform, and work with numerical data. This data will be used to tell engineers if there's a significant change in the temperature of a probe. So let's take a look at the data in this specific Power Query editor. So inside of this data, the first thing I'm being drawn to is the fact that the column names haven't been labeled correctly. And I can see that there is something different in the first row. So the first thing I'm going to do is just set my first row as headers by clicking the value inside of my homepage. And now I can actually start making a few inferences here. So I can see that there is, if I zoom in just a little bit for you, there is a date column, a factory column, device name, of probably about the probes and the temperatures that these probes are recording. I also noticed that there are quite a few empty rows in here, but I should check if this affects all of my data values. So one thing that I can immediately do is jump into my view. This is this little view ribbon button and click this data view to enable the column profile. Again, it may look different depending on your Power BI variant, but it will be there. So the first thing I can see is, one more time, is that these rows are 100% empty. This row contains some errors, and these device names look fine. So I'm just going to immediately rename this, remove these specific queries. So if I remove, I right-clicked, I click this remove button, and you can see that a lot of the transformations that I do are also found in the ribbon tab. It's the same transformations required. If I wanted to move multiple columns, I can use the Shift key. If I want to use specific, select, but also multiple columns, I can use the Control key. Now, I'm now going to turn my attention to focusing on these errors. And something doesn't seem exactly, let's just see. Something doesn't seem like there seems to be a bit of a trend in some of these data columns. So what I'm going to be doing is, I think it's something to do with the date. If I just scroll down a little bit, it just happens in bursts of data. So let me just first split this date column into date and time, because I can see if I zoom in again that it happens every 5 seconds, a new value entry is incorporated. So I think that might be a good idea just to split these two together. So I'm going to right click this and I'm going to click this split column button that I have available to me. Actually, what I'm going to do is I'm going to duplicate this. And I'm going to move these two next to one another. And this one's going to be the date, and this one's going to be the time. And then I'm going to change the types. So date. And then for this one, date, time. Actually, that is date, time. So we want to use time, just time itself. Replace current. Thank you. All right, so now I have two specific columns that will, one which will tell me the date, which will be useful if I needed to granulate them all. I can see for this specific section so far, it only includes the first, only one specific date, but the timing changes. So now I want to just play around with and identify how I can fill these errors. So because I can't do anything about these errors, I don't know the exact cause. I need to talk to the engineer to identify them and they can get back to me. What I'm going to do is, rather than remove the errors for now, is to just replace the values with empty rows. So the way I do that is I'm going to click this replace errors button. And then I'm just going to put a spacebar, which will then represent null. So now all I can do is either choose to filter this out or work with it. So I'm noticing I've noticed a little bit of a trend here. So if I click on this filter button and I take away the first values, if I filter these values, this is my hunch. They're all empty. So I don't think I need these in my report for the time being. We can, again, when the engineer comes back to me with the fix, we can potentially incorporate them once more. But for now, we just take them out and we'll deal with it down the road. So at this point, I have some data points which are very, either value is missing something or it's at a specific time in the date. Is this also 0515 as well? No, some of them they're still in there. So what I'm going to do now is we're going to just leave those blank because some of the data is existing. Is I'm noticing the next thing my eyes are being drawn to is that this is 9999, which if you think about it in terms of temperature in Celsius is hotter than the sun. So we probably don't think that's going to be correct. And if it was hotter than the sun, we've got much bigger problems to deal with. So if what I want to do is I want to go set an outlier. And this is, again, calling in on your subject domain experience. And I spoke to the engineers and they're like, oh, the hottest temperature our factories have is up to 1,200 degrees. So what I can do is if I right-click this, I can basically go, I can filter the values out. Actually, if I use the down arrow, here we go. If I filter the values out, it's not, I need to change the types as well. So let's just use this to decimal number. The rest should be fine. Yeah, cool. So if I click this little down arrow, I can then filter this value out. And you can see, for instance, here, that this is also quite a big skew in my column profile view. So I want it to be less than or equal to anything that is smaller than 1,200 degrees. Now, the purpose of this specific data set is that we want to identify if there's a significant change in the temperature. We know that the maximum value is 1,200, so and if it's at this 1,200, it means that there's something that's going wrong and the engineers need to be alerted immediately. So what we're going to be doing is we're going to then set some form of conditional approach to the data set to say, hey, when it's between this value, because now if I click this specific column, you will see that the range of the data set somewhere lies between 800 degrees centigrade and 860 degrees centigrade. So that's around the normal value that we have available. So what do I want to do? I want to create a condition to say, hey, if it's smaller or larger than a specific value, give me a traffic light system. Like green, it seems to be around this 860 mark. Maybe orange goes to 950. Again, it will depend on your use case, how you use transformations to make it need. But what I'm doing is I'm navigating to my ribbon bar to this add column section. And you'll see that there's this conditional column available. And if I click this, what you will find is it will say, hey, give your column a new name. So I'm going to give this to say a temperature flag, or not a flag, it's more like temperature condition. And inside of here, I can then set up my column name. So if my value is higher than, for instance, 1,100, we know 1,200 is a really bad time. So let's just put in 1,100 to give our engineers a little bit of time to jump into it. Then we should give it a red situation. If the value is, let's do equals or higher, greater than or equal to. If the temperature is greater than 950 degrees, then I want to basically say, well, we should be paying a little bit of attention here so that they can walk away with it. And lastly, if the temperature is, well, actually, there's nothing else that we need to worry about. So let me just delete this. You'll find Power Query is quite forgiving when you need to make some changes to it. Because again, transformations is a very iterative process. If I click OK, what you will find is a new temperature. There's a new column that applies with this new column. Now, I can then, let's say I was going, okay, you know what? This isn't really what I want to call this column. I can rename this to KPI warning metric. So I'm just trying to make sure that in the future, if anyone comes to this, they will go, all right, this is what this column represents. It represents the KPI that releases a warning based on the specific temperature threshold. And I can also rename my data set. So if I right-click this, right now it's referred to as the sheet or the data set that it came from, and I can say, hey, this is going to be my temperature data set. And there you go. This is a relatively small data set, so it seems to be, everything else seems to be all in order in terms of the numerical values. So I think we will call it a day and apply the data set. Let's just double check that it looks the same inside of my Power BI semantic model at this point. So this was the previous values before, right? And it's just loading the data into my environment. And if I click on this table view, it will show me my changes available. By the way, this was just a sample of the data set. And when you're first starting out with data, you should always start off with a smaller sample just to see how to bring things in, and you can always make changes along the way. It's a very iterative, it's a very forgiving experience for you. So there you have it. An example where you can transform numerical data and work with it by filtering, handling out errors, setting up conditional columns. I mean, I only just scratched the surface of how you can experiment with it. And as I pointed out, my data was a sample. There weren't that many numerical issues, but I can safely say it's ready for the next stage of transformations, which would be me working with my categorical values. I'm going to show you an example of how I would use Power BI to clean, transform, and work with categorical data. This data will be used to tell engineers if there's significant change in the temperature. So let's take a look at this data. We have the columns which contain the date, a time, a column containing factory, a column containing the device names and the device types, and a temperature along with a custom column. Now, I'm only interested in the categorical side, and what I'm being drawn to right now is this device name here, because the first thing I'm seeing is that there are empty rows in this specific data set. So what I'm going to do is I'm going to just do a little bit of investigation. Let me just zoom in a little bit here, and I can see that out of these null values, let me just filter it, out of these null values, where do they occur? And when I click that, I see that there's a common trend that it seems to be happening with device 0, but it doesn't seem to appear anywhere else. So one thing I could do is if I know that this only occurs to one specific value, I could use replace values. But as I'm working with a sample data set, if in the future more data comes in and these nulls do not associate to this device, that might cause problems. So how I'm going to address this is, let me just show you everything again. I'm going to filter by the device. Well, first I'm going to duplicate the table, and then I will filter by the device. And the reason I'm going to do this is at some point I'm going to bring it all back together, but I want to make sure that it only applies to the furnace values inside of my column. So this is going to be the furnace one. So let me just filter this out by device 0. And then I can do the replace values. Now this will ensure that every time this specific data set encounters a problem, it will make changes only to that value. So we're going to take the null and we're going to replace with furnace to match the rest. There we go. And in this temperature probes, because I now have a data set that contains this furnace, I don't need that anymore. So I'm going to filter out device 0 from this one, just simply by unclicking or unselecting the box. And at some point, I will merge the tables together. Actually, not merge, I'm going to append. And the reason why I'm using the append is because all of the columns in both of the tables are shared. So this makes it a lot easier to just append data that exists before. So if I click this append queries button, it gives me the option to either append multiple tables, and if I click the little down arrow, it gives me a new option, which is to create a query as new. And that means I just basically create a whole new table from scratch. So let me just append queries. I think it's good enough for the situation to overwrite the data. So we're going to append this furnace table. And now I have this data set now existing in the main one. If I scroll down, the furnace exists here. Now let me just take another look at my device name. And inside of my device name, if I look very closely, I can see that some of the words are duplicated. The profiling tool can also help here, but I can already see straight off the bat that this is going to be very relevant to me. So what I'm going to do is I'm going to pick one and rename it. I could also rename both of them to something that I prefer. I'm just going to have this all be referred to as cement kiln. Now, the other thing which I noticed here was that the cement kiln is all lowercase, whereas these ones all have some form of camel case setting. So I'm just going to make sure that everything will always be the same. And I'm going to change the column type using these text transformations to become uppercase. And this means that in the future, if any type of text comes in, it will always just convert it all, so we don't have to worry about mismatches in the data. So everything is now uppercase values. So now what I'm going to do is replace the values once again. Because this should have happened to everything. Cement kiln to cement kiln. Same one. There we go. So now what you will see, we have 4 distinct values. And if I click this OK, it should drop to 3. There we go. 3 values now remain. So I think that column's pretty set. Let's look at some of the other things that we have available. Now, if I look at this factory, what does this factory actually mean? Well, I'm going to make an assumption here and say that this value represents the country and this value represents the city in which the factory is located. Now, this is because I have a bit of knowledge. I spoke to the engineers. They clarified what that meant. So instead, what I'm going to do is I'm going to split these values based on this little hyphen here. So where is it? It is the split column value. I'm going to use this by delimiter, but just note that there are different ways you can go about it. I can use this custom value to then set the value. Just also note that there's this advance if you need to be a bit more controlled in what you want to do. But mine is just a hyphen, not the most intense workload for it. And if I take a look at that specific column, you will now see that I have 2 columns, factory 1, factory 2. Let's rename them to our country. Double clicking there. And I've also caps locked it. So let's be nice, good, clear column names. And double click city. Wonderful. So now I have this country name and city. There's one last thing I think might be a good idea. And that is to work with this device value. And the reason why I'm saying, hey, we should probably change this value is because in Power Query, numbers take less memory than categorical strings. So where possible, if you can convert something into a number, you can. And if I look at here, there's always a number here. So what I want to do is I just want to take that device out. Again, what I recommend is you always standardize how you go about this. For instance, in the future, if someone enters the device name incorrectly, this always just makes sure that you will be able to come back to it and it will always have the same value. So I'm just going to use uppercase for now and then replace the word with device to just nothing. We don't need it. You just take it out. And that means that I can now convert this to a type. So this is a whole number and it's now an ID, which will take less memory in the table. So that is my categorical table prepared. Now, if I were to close and apply this, actually, let me just do that and show you something. If I were to close and apply this, you will find that now the data goes from not just one table, but 2 tables. And this is because this furnace table that we created earlier created a new data set. So how do I deal with that? Well, let me just jump back into the Power Query editor. What you will find is that there's these little buttons that you can do. So I renamed the query edit earlier by right-clicking it. I can also enable and disable my load. And by doing this enabling and disabling, what this means is it says, I want you to use this data. At some point, maybe another table will reference it. If I right click here, we can also reference our data. But at some point in the future, I want to use this table, but I don't want you to actually store it in memory. So only do it during this transformation part. If I use this reference, what it does is it doesn't create a complete other table. It just says, hey, we're going to use that existing table as our template. It tends to use less memories. So let me just also reduce this in the report refresh because the temperature probes will do that for me. I'm going to click this close and apply, and what you will find is the table disappears. Voila. So there you have it, an example where you can transform categorical data and work with it by filtering, handling errors, renaming values, splitting columns, and working with text transformations. I've only scratched the surface of how you can experiment with it. Again, my data was a small sample, and there weren't that many categorical issues, but I can safely say that we can now start to think about how we use this data for modeling. Take some time to see what kinds of transformations you could apply to it, and based on a specific problem that you're wanting to work on. Let's discuss performance recommendations when it comes to working with the Power Query Editor. The documentation suggests that for data transformations, you should keep only the necessary data, prefer numerical transformations over text, and minimize the number of unique values. My personal recommendation is to do your data cleaning at the source, whenever possible. Get into the habit of treating Power Query Editor as your backup. Yes, it is capable of meeting our transformation needs, but when we start delving into larger semantic models and data sets, it takes away valuable compute. But not all scenarios will grant you the luxury to work with the source. So here's what you should focus on to improve your performance in Power Query. Firstly, not all data will be used later, so trim it now before it gets to the designing of your report. Otherwise, you can always go back and remove it when you know it's unnecessary. By trimming, remove your columns. Use parameters when you notice multiple transformations end up using the same value. Next, I would probably check the data types before loading. Numerical transformations are faster than dealing with text transformations. So check that you use integers for IDs instead of strings. And use dates instead of date times where possible. Ask yourself, what is the granularity your users need to know in order to make the best decisions from the data? If it's daily, aggregate and summarize hourly information, and so on for consistency. However, summarizing your data does have a drawback. If your users want to drill into every single transaction, summarizing the granularity will prevent them from doing that, which can have a negative impact on the user experience. So it's important to negotiate the level of data granularity with report users and the use case itself. Users should then understand the implications of these choices. If working with a single category, you can also filter by a parameter which allows reuse for multiple transformations. For instance, maybe your report only works with one country. Then we have cardinality. Cardinality is how many unique values there are in a column. The more unique values, a higher cardinality. The poorer the performance, though. Here's an idea to help you think about reducing cardinality. Maybe the outliers get grouped as others or dropped. You standardize your naming conventions in the categorical column. The goal is to reduce cardinality to improve performance. And not all data needs to be reloaded every time you refresh the data. For instance, you combine and merge your data into a new singular query. You can't delete the older tables because they're being used in this new table. So the next best option is to stop them from being loaded into your semantic model. This still allows Power Query to work with them as connections, but reduces the load, therefore resulting in a smaller model size when it comes to publishing your data. The main advice is to keep only the necessary data, prefer numerical transformations over text, minimize the number of unique values, and avoid loading data that is not needed in the semantic model. There's a lot of documentation out there, and that will show you how to do it. And I recommend taking the time to dive into precisely that. In this video, we explored how you can best optimize your transformations in Power Query Editor. We touched on how it's important to think about data types, data volumes, and removing unnecessary data before or during your report for development processes. For instance, if you're working on a report, ask yourself, is this data actually being used? And be sure to check out the documentation for more useful tips and information. Let's dive into some advanced concepts behind Power Query. We'll look at query folding, and other more complex transformation asks that you can work with. A query is a set of instructions that tells Power Query how to get and transform your data. You can create a query using the Power Query editor, write it yourself in the advanced editor, or start with a blank document. All queries use the Power Query M formula language, which has its own functions and syntax. Power Query uses M not only to create, but also to execute these queries. But how does Power Query actually run your queries and get the actual results? Well, this is where a concept called query folding comes in. Query folding is the ability of Power Query to translate your M code into a single query statement that can be executed by the data source. For example, if your data source is a SQL database, the Power Query editor can generate a SQL statement like group by, sort by, where, or some source equivalent that performs the same transformations as your M code. The benefit of query folding is that it makes your queries more efficient and faster. Instead of loading all the data from the source and then applying these transformations in Power Query, query folding allows the data source to do all of the heavy lifting and only return the data that you need. This reduces the amount of data that Power Query has to process and the time it takes to refresh your queries. However, query folding is not always possible. Some data sources, such as flat files or web pages, do not have a query language that Power Query can use. Some transformations, such as appending or merging queries from different sources or adding custom columns with complex logic, cannot be translated into a single query statement. And in these cases, Power Query has to retrieve the data from the source and then apply the transformation itself. The consequence means that it results in slower performance and becomes more resource intensive for larger data volumes. For every query, transformation, source ingestion that you create, the M equivalent is also generated. You can see this here. If you get comfortable with M, you can even dive into the advanced editor and write the cleaning and pre-processing steps needed. It's completely optional, but understanding it does help you understand how the steps are approached and written. So, why is this considered advanced? Well, the ordering matters. If you focus on delegating as much processing to the data source as possible, it improves the processing time of transforming that data. So wherever possible, move the steps that allow query folding as earliest as possible. And this is where the knowledge of M makes it easier to adjust those changes. Lastly, if the query is prevented and you're using a relational data source like a SQL server, try using a native SQL query command shown in front of you. In this video, I wanted to emphasize the importance of query folding. For best performance, try and incorporate it as much as possible that all steps are able to fold into the previous ones. For now, if you have a transformation you're working on in Power Editor, check out which ones allow you to do a native query and which ones don't. And how can you improve that process? Until then, keep learning anytime, anywhere. I'll see you soon. At this point in the data journey, we've ingested our data into the Power BI environment and learned about the different ways we can go about cleaning it. We now have a blueprint that tells Power BI exactly what we need it to do when it comes to pre-processing the data. The challenge now is that if data is coming in from a variety of sources, we need to think about how we can bring it together regardless of whether the end result has the makings of a complex system or a simple one. It's important to make the experience as intuitive, not only for us, but for those who also plan to work on the report in the future. This is why I say now that you should approach this section from the perspective of future youth. Be kind to them. For instance, think of future you in 6 months' time who will return to the project. How will they overcome learning all of the steps you took in building this report again? Our data model will start to form the foundations to allow us to view our data in an understandable way. This next section will jump into the concept of data modeling, which means we let us design our data in a way that can be easily digestible by building schemas in a visual format and diving into working with relationships and discussing the best techniques that allows you to get started. Have you ever found yourself wondering what to do after you have imported and transformed your data in Power BI? The next step in our data journey in Power BI is to bring all of our data together by creating links, building the tables, and building semantic models. Let's introduce data modeling. In Power BI, we use the term semantic models to describe the data used in our reports. This data is ready for reporting and visualization. Power BI is designed to support multiple sources of data, so it's important to define how the data is organized and establish relationships between them. However, we don't want to join all of the data into one master table, as this can create duplication, slow down our compute and engines, and make it quite difficult to manage security protocols. Instead, we separate the data into segments or tables that are designed to meet our business needs. These tables are usually split into two categories: fact tables and dimension tables. Fact tables store measurements, observations, metrics, or activities of a business process, while dimension tables store attributes or details related to those activities. This allows us to filter and aggregate our events and observations. An example of data in a fact table could be an event logging an employee making a sale. A dimension table could provide us information about the employee or the customer. And when you have many dimension tables, such as a date table, an employee table, or a customer table, it is referred to as multi-dimensional modeling. Creating a well-designed data model in Power BI offers numerous benefits, including enhanced data understanding, simplified report building, faster data exploration, simpler aggregations, more accurate reports, and reduced future maintenance efforts. A popular smaller data model is the star schema, where a fact table is connected to several dimension tables. In the star schema shown in front of you, we have a singular fact table connected to 5 other dimension tables. This separation simplifies the data and provides a clear hierarchy and context for analysis. By connecting the fact table to these dimension tables, we establish relationships and determine the level of detail in the data. In Power BI, we use semantic models to capture the relationships and organizations of hierarchies and smaller details, similar to how schemas are used in a relational database, like a SQL Server. So, how do you combine your fact and your dimension tables? Well, you identify columns that are shared between 2 tables, and this is what we refer to as a relationship. So whenever you point to one, it will know where you are referring to it if there's multiple rows in that dataset. This could be an ID or a column that shares values. Sometimes this requires a little transformation in itself, like concatenating values too. Once you have designed your chosen semantic model, you can then start thinking about a process of validation. For instance, you create a report, and in that report, the validation will perform checks that the data is accurate, consistent, and available. If necessary, cross-referencing to the source can ensure that the data isn't lost or even excluded. When correctly built, it's often a moment of triumph, a sigh of relief, the process of organizing chaos. It takes work, but implemented successfully can be a game changer in a successful narrative and beyond. We discussed what semantic models in Power BI are. They are used to organize and relate data from multiple sources for reporting and visualization. we introduced the star schema, which is a type of semantic model that consists of a fact table connected to several dimension tables. Once we build a semantic model, we should take the time to validate it. Your challenge? Start building a well-designed data model in Power BI. Approach it from the star schema method. Find a fact table and connect it to 2 or more dimension tables. Let's discuss how you go about working with your data to build a star schema. The goal here is to reach a star schema. Everything here happens inside of Power Query. If you have a big data set that includes everything, then your goal will be to break it down into smaller chunks. I do want to point out here that there is no table property that determines whether you can configure the correct table type to be a fact or a dimension table. It's actually determined by the model relationships. However, as a guiding principle, first ask yourself, what are the observations? Can it be summarized? If yes, you have a fact table. If no, check to see if it helps towards you answering the who, the what, the when, the where, the why. Can the data here be used to filter or group the observation? And if yes, then you have the makings of a dimension table on your hands. A dimension table can also be segmented further. I recommend at most 5 categories. A star shape also has 5 points. So you should consider having 5 categories to equal 5 dimension tables. But it's not the end of the world if it has more or less. This is very use case dependent. To split a dataset, you can reference or duplicate the original dataset. I recommend using the reference over the duplicate as it will consume less resources, especially when it comes to data flows. Also, make sure to disable your load on the original dataset and split accordingly. Just make sure that there will always be a column like ID that allows you to join both datasets together. Let's use this demo to show you how to work with a star schema and create it from a master data set into the smaller chunks. So in front of you is a master data set. It contains the date, the time, the country, the city, device name, and the temperature Celsius. So the first thing I want to ask myself is, what are the observations? And in this situation, it's actually the temperature. So I know that this is my fact table, which means that I can technically convert all of these other variables into a dimension table. Now, I'm only going to just show you 2 today. So we're going to do the country and city and the device name as well, just as an example. So let's start with the country and city. Let me duplicate my table. And inside of this, I'm going to rename it to geography, because that is the main theme behind country and city. Geography dimension table. And I'm renaming it to make it easier for me to work with. And inside of these tables, what I'm going to do is select my columns, remove other columns I have available. And because we have a lot of repetitive behavior, all I have to do is highlight both of these columns and remove duplicates. So it will check which ones come with distinct. One last thing though, right? We need to add in our lovely index. So let me just jump back into the add column, create the index column, give it a name, geography index, and move it to the front. You don't have to move it to the front, but for me, it makes things nicer, smoother for me to translate when I look at this. Right, so that's the geography dimensions done. Let's now take a look at the device and the device names. So what I want to do again, I take the main table, I duplicate, I rename to my device dimension table. And inside of this, again, only selecting the columns I want. So jump into home, remove columns, remove other columns. Of course, I can also just right click and it will also do the same thing. So again, doing the exact same thing where I am removing duplicates. Adding in my index, renaming my index. Let's call this the device index. And then reordering it appropriate. So now what I want to do is jump back into my temperature value. So we've created this dimension table. We now need to start thinking about our fact tables. We have these tables available, but what I want to do is actually bring these indexes that I have just created into the main table. So how do I do that? Well, I'm going to merge it into this main fact table, this temperature fact table. So what I'm going to do is I'm going to use this home. I'm going to merge the queries, and I'm going to start with the geography. So if I click this geography dimension table, let's just work with the city because that provides the least number or the lowest granularity that I have available. And we'll do a left outer join. Oh, need to select the city for this one as well. Wonderful. So then what you will find is that it will open up this table, and the only thing I'm really interested in is actually the index. And now I have the geography index installed. Denmark, Copenhagen, 0. NL, Amsterdam, 1. Sweden, 2. And Stockholm in Sweden to 3. So I have the data ready. Let's do the same for the device. Merge query. Choose the lowest denominator, which I believe is actually the device. Click the table I want. When I'm ready, just join it across as a left join. So this will be merging into my fact table. Click OK. Again, following the exact same steps. Only interested in the device index. So now what this means is I can take these data sets that I've just created, these tables out, and I can delete them, remove them from my data set. So remove columns. And for consistency, let's bring these two to the front. Bring in my device index to the front and add my final index, which is the temperature. So this is my main temperature probe, just in case at some point these need to be added as well. So as you can see, it's more numerical based. It contains less strings, and I could put this KPI warning in its own dimension table along with the date and time. And when I'm done, I close and apply, and what you will find is that Power BI will do the rest of the magic for you. Let me just pull this into view. There you go. So there you have it, an example of creating a star schema from a master dataset. If you have a small dataset that needs to be joined, like appending data across the years or joining two queries together, you can use the append or append as new, as this will create a new table. Again, always remember to disable load on any original datasets where you can create improved versions. Our goal is to create a star schema, so I recommend you aim for a 5-pointed dimension. You can always merge datasets together. Some categories are easy to merge and pair, like geographies, where you can join countries based on cities and towns. Products can be split into subcategories, and these can be merged into their categories. Sometimes in your data tables, data can also be represented awkwardly, and they are pivoted when in reality, we actually wanted them to be in a singular comment. And we can pivot or unpivot based on our desired output. It's reversible, and of course in Power BI, you can also just reverse it by deleting steps to go back and forth. When I have my desired query, I can then start thinking about how I can use groups to organize my query pane, placing the hidden queries into supporting tables, the original, and into semantic model queries. And again, if I deleted it, any reference data would show me errors. By separating my data out, I am removing the categorical references, which will increase computation speed down the line, as well as providing security benefits like using row-level security. I will say that it's better to do these steps outside of Power BI, but if you're not in a position where you can work with the source data, now you have an example of how to work with fact and dimension tables. So there you have it, an example that explores creating a star schema from a larger data source. You can also put this all back together using the merge function. And in this video, we explored how to transform our data so that it follows a star schema design. Some ways you can do that is by merging or appending to combine data into singular tables and then using a pivot to reduce cardinality where relevant. Take some time to try each one of these components on a sample dataset to make sure you fully grasp the concept. Let's talk about relationships. Our relationship is good, but it's time to dive into how we work with relationships inside of Power BI. A model relationship is like a bridge that allows filters to move between two tables. The movement of these filters is determined by the cardinality property of the relationship. It's about how many records in one table are related to records in another table. This property tells us the different types of tables. There are 4 different kinds of cardinalities that exist within Power BI semantic models. One-to-one, where each of the records in the first table is related to one and only one record in the second table, and vice versa. We then have one-to-many, where each record in the first table can be related to one or more records in the second table, but each record in the second table is only related to one record in the first. Then we have many-to-one, which is the inverse of one-to-many. Again, each record in the first table is related to only one record in the second table, but each record in the second table can only be related to one or more records in the first. Then we have many-to-many, where each of these records in the first can be related to one or more records in the second table, and each record in the second table can be related to one or more records in the first. In Power BI, relationships can be done via dragging and dropping the column names between our tables. In the Power BI desktop model view, you can interpret a relationship's cardinality type by looking at the indicators of one or the star on either side of the relationship line. In order to determine which columns are related, you should be selecting or hovering your cursor over the relationship in order to highlight the appropriate columns. And when we compare this one side, it's usually a dimension type table, while the many side is either a dimension or a fact. We can also determine how the filters move across the data. Cross-filter direction in Power BI refers to the direction in which the filters are applied across tables in a relationship. It can be set to one of 2 options. Single, which is where the filter is applied from this primary, this one table, to the related or many tables. This is the default setting for one-to-many relationships. You also have both, and this is where the filter is applied in both directions, from the primary table to the related table and vice versa. And this setting effectively makes the relationship behave like a many-to-many relationship. In other words, we can determine which parts of the data are affected when we apply a filter. This is especially useful for when we have large amounts of data and we want to focus on specific parts of it. It's like choosing a path for the filter to follow in our data. Let me give you an example. Suppose we have 2 tables, a book table and a sales table in our store. Inside of this table, we are able to, let's say I select a table on this science fiction option in the genre. This allows me to filter just this specific column. But let's say I jump back into my model view and I go, hey, actually, let me create a relationship between these 2 options. So let me grab this book ID, hover it over here. And again, I can always hover my mouse over it and it will point out that the book ID is the relationship. Now, if I click on this specific line, you will find that it is a one-to-many relationship option, and I can interact with the direction filter. Again, let me show you what happens now when I've set this relationship up. you will notice that this January or the specific other table filtered itself out. So now if I unclick it, more options appear to me. So this means that the data will always get updated when I click the book table. If I try to do the reverse, so let me just undo the filter. One click, unclick. And I try to select a specific month, like February or January, it won't let me actually filter the data. So in order to do that, I would need to jump back into my relationship. Let's actually use this manage relationship option here and select it so that it is, instead of single, both. So this now means that both of the filtering will happen in either way. So now if I select February, the table changes in this side of things. If I unselect February and try and select science fiction, the filtering happens on this specific table. And that's what we talk about when it means cross-filtering. I can interact with how the table filters from my one-to-many, many-to-many relationship. It's important to note that whilst the both setting can be quite useful in certain scenarios, it can also introduce ambiguity and performance issues. So use the many-to-many with both with caution. We explored how to create relationships in Power BI and discussed the importance of cardinality and filtering when designing your relationship. So here's my challenge to you. First, create a relationship between a one-to-many and also one between a many-to-many. What are the differences in the specifications that you get? Modeling data is about establishing and maintaining relationships so that you can effectively visualize the data in the form that your business requires. When you are creating these relationships, a common pitfall that you might encounter are circular relationships. We're going to be discussing bidirectional relationships and how they can impact your data model. Bidirectional relationships can be powerful, but they also introduce ambiguity in the filter propagation path between model tables. And this can lead to what is known as a circular dataset. Let's explore this concept further with an example. In my Power BI environment, I have three specific datasets. I have my sales table, I have my authors table, and I have my book genre table. And they are all syncing up with each other. Inside of my data, the book ID columns forms the relationships between the book and sales data. So this guy applies to both of these. And as well, in the book and author table, we have the author ID interacting with this favorite author tab. Let's just check that we have, inside of both of these tables, we have set up a both directional cross-filter in all of the tables that we have available. And for instance, if I were to apply a filter, and let me just jump into the view mode, the report view, if I was to jump into my specific table and let's say we filter the books to only show science fiction, what we will find is that our sales table will get updated to only show those science fiction of all of the sales, along with our authors appearing on the right. Now, if we apply a sales to that specific table in January, you will then find that it will filter only that specific author who released or made a sale in that January section. This is an example of how the data can be ambiguous, but let me just show you a problem. So in my data set, let me unfilter these values. In my data set, what you will find is that not all ID, there are multiple IDs. So in my author ID table, I have A1 to A5. But actually, if I jump into my data view and then I'm into my sales table, you will find that there is a table for A6. But that doesn't exist in my table. But let me just show you what happens if I were to filter by this A6. it will still try and show me a different author's name, right? So this is an example of where the data can become ambiguous. It means that the data doesn't entirely exist. And if I were to filter it on that specific table point, it just no longer appears in the results. So this filter propagation path between the table and the data model becomes this circular data set where you can start to follow one table. Let me just jump here and create a loop to the remaining tables. Now, the ambiguity rises because there's going to be multiple paths in the table, and it's unclear as to which ones will be followed. And there's also a few further drawbacks to following this kind of approach. Firstly, it can also cause performance problems as the engine will need to perform extra work to resolve the circular references. Secondly, circular tables can make the data model more complex and harder to understand, and this can make it more difficult to maintain the data model as well as ensure its accuracy. And thirdly, circular tables can lead to data integrity issues as shown, such as redundant data or inconsistencies between the data, like the inconsistency should the favorite author in the sales table not match the author ID in the book ID, it could lead to inconsistent results. If a sale record has book ID 6, which corresponds to the author ID A5 in the table, but the favorite author in A6 exists, it could confuse the analysis. Pause the video, go back and see if you could have spotted the difference and problems here. So to resolve this ambiguity, Power BI uses priority tiers and relationship weights. Priority tiers define a sequence of rules that Power BI uses to determine the filter propagation path. You'll see I have an active relationship inside of my model, and I can identify this active relationship based on this straight line. This is an example of an active relationship. We also have indirect relationships using this dotted line. So if I tried to, for instance, make this data active, let's just double click this and then say, hey, I want this to be active, I will receive a message that says you can't create a directive active relationship between the sales and author tables exists. So it will tell me off when I make a mistake, I'll get an error, and if I wanted to achieve it, I need to make sure that I use a specific DAX query or change the priority of the direction. Again, if I wanted to fix this specific problem, I would be using the priority change options by changing the direction, or alternatively work with the DAX query such as the use relationship function to resolve any ambiguity between multiple paths in the same priority tier. Bidirectional relationships in Power BI allows filters to work in both directions between a model table, but can also create circular references and ambiguity. This can create problems in performance, increase in complexity in maintaining the model, and also lead to data integrity issues. While Power BI does have the method to resolve relationship path ambiguity, it's best when you encounter such a scenario to know how to identify and as well as handle those circular tables. Learn anytime, anywhere. I'll see you soon. At this point in the data journey, we've ingested our data into the Power BI environment and performed data modeling techniques that will help us easily get absorbed into our data analysis. In our current blueprint, we have a data model which contains relationships on data ready to be analyzed. Now that we've laid that groundwork for data modeling and established our data relationships, it's time to dive into the exciting world of data analyses. Our data model serves as the backbone, connecting different data tables and providing a structured view of our information. This next section introduces how you will go about that analysis. We will be utilizing the inbuilt storage and engine Vertipack, which will be paired with DAX. DAX is our programming language, and it's used to build and create custom calculations, aggregations, and measures inside of our Power BI environments. When you write DAX expressions, VertiPack processes them to retrieve the necessary data from the compressed storage. And these DAX queries are executed against the VertiPack database. This efficiently retrieves the required data columns and then performs the calculations. VertiPack handles the heavy lifting of data retrieval, aggregation, and filtering, allowing DAX to focus on business logic and analysis. Let's get started. Learn anytime, anywhere. I'll see you soon. DAX, or Data Analysis Expressions, is a powerful formula language used in Microsoft Power BI, Excel, Power Pivot, and tabular models. Its purpose is to create custom calculations, manipulate data, and generate insights. With DAX, you can explore totals, rolling averages, monthly trends, year-on-year percentage growth, profit margins, customer segmentation, row-level security, and inventory management, among other things. But DAX isn't just about basic math. It's also about advanced analytics, where you can use it to forecast, simulate, and identify trends. Let's talk about DAX from a high-level overview. Think of DAX as the Swiss Army knife of data analysis, a language that allows you to create custom formulas and perform calculations on your data. It's the bridge between raw data and meaningful insights. Inside of Power BI, you can use DAX to work with tables, columns, measures, and functions. And when we talk about tables, we mean both actual database tables from a source and virtual tables that we create using DAX. And it exists within our semantic model like a date table. The real magic happens when we incorporate DAX into measures. Measures are dynamic calculations based on columns that aggregate, slice, and dice, depending on the functions that we use. DAX provides a rich set of functions like sum, average, and count rows to build your measures, and those are just a few of them. A typical DAX formula follows this pattern. Calculation name equals DAX formula. Let me just show you this very quickly. So, calculation name equals DAX formula, right? That's what we're going for. So if I wanted to, I could essentially say, all right, I have this data set which contains the temperature and there are devices inside of it, right? So I have this device index and this temperature Celsius. Now, what I'm going to do is I'm going to refer to this in its own way. So I'm going to say, all right, let me then just take, for instance, the average row. So temperature average per device index, right? That would be a good naming convention. So whenever someone comes back to it, they will know. And what I would be doing is, for instance, applying my formula. I'm going to pull from my own library and I'm going to take the average X function and I'm going to say, hey, let me apply this filter that I want to work with. And in this, I'm going to refer to my tables. The syntax for referencing a table is identified using these two little quotation marks. And you will find that when you want to reference a column, it will use the square braces opening and closing. So we're using the device index here as my example. And I'm going to close off all of my variables, right? What's gone on here? Then what I'm going to be doing, it's all three of them. Then what I'm going to be doing is I'm going to say, let's calculate the total number of temperatures, or the total number per every row inside of it. I'm going to use this calculate function, which will be filtering by our column. So if I take the sum and then apply the probe table, there we go, fact probe table, and I use my up and down arrows to navigate through it, I will find the Celsius column that I want to work with. And then I close it off and then close off the whole entire function, right? And I can make this bigger because, again, it's designed so that you can organize your code as in how you want to see it. So I'm pressing the Alt and Enter key involved here and just trying to clean up my table. Now, you will see inside of DAX that it's telling me, hey, there's something not quite wrong here. We're not quite happy with how you've created this table. So what I need to do is just quickly understand what's going wrong. So what you can see here is we have a function that DAX understands, and you'll see that in black, it represents something that doesn't exist. So I would need to check the documentation to find the right value, but I just wanted to include it just to show you what needs to be done. So let me just put in the correct function. You'll see that the whole thing changes, and I can press Enter. And what it creates inside of the table that I have is a brand new table, or a brand new measure that I can play around with. And I can take this value and, for instance, put it inside of my model view. So in this example, the average table per each device index ranges around 8K, which makes sense because there's about 10 rows for every data set that exists. The formula can be a combination of functions, operators, and column references. In Power BI, you can use different calculation techniques and functions to create measures or calculated columns. The key here is to know how and when to apply them. By having a basic understanding of when and how to use each technique, you can then create robust and high-performance data models. When designing your analytics query, approach it with an FGS mentality. Filter, group, summarize. This allows for the most efficient processing of the data. And while not all 3 steps need to be included in a DAX query, it's the order of implementation that matters most. First, filter the data to remove any irrelevant information, reducing the amount of data that needs to be processed in subsequent steps. Next, group the data based on specified criteria, allowing for this aggregation and summarization. Finally, summarize the data to provide the desired output. The order of operations ensures that the query is processed in the most efficient manner. Just remember the acronym FGS. Filter, group, summarize. DAX bridges the gap between raw data and meaningful insights. It is your Swiss Army knife that can be used to create custom formulas through measures and perform calculations on your tables and columns. Take a data set that you are comfortable with. Choose a numerical column and create a new column that multiplies that value by 3. I look forward to seeing how you get on, so continue to learn anytime, anywhere. I'll see you soon. Using DAX, there's different ways we can solve and address the same problem. But which one should I go for? Let's discuss the differences between measures, calculated columns, and tables, just to name a few. Working with DAX often means that you have the ability to create, analyze, and build a programmatic way. We will be using measures, calculated columns, and calculated tables to do this. A measure is a dynamic value that changes based on what you're looking at in a report. It aggregates or summarizes values within a column, considering the filter context of that visual. You will want to use measures when you want to perform calculations on aggregated data like total sales or average profit, or for dynamic responses to user interactions like slices and filters. Measures are evaluated in the context of a cell within a report or DAX query, and they are not stored in memory, but actually computed on the fly. Then we have calculated columns. Calculated columns are a static value that is added to an existing table. It's calculated row by row when you load in that data. It will extend that table by creating a new column based on a DAX expression, and is evaluated for each row. Power BI creates the column, so it doesn't make any changes to the underlying dataset. You would want to use calculated columns when you need to add new data to your model, like changes from existing columns, or for filtering, sorting, or displaying additional information. This is particularly useful for when you're going to be using this column frequently for many of the visuals in your report, because calculated columns are computed during your processing steps, like when you're building your Power Query transformations. And then it's stored in model, occupying memory space. These columns will be updated when a dataset is refreshed. They are particularly useful for these complex calculations that benefit from pre-computation. So when to use what? The fundamental difference between a calculated column and a measure is that a calculated column creates a value for each row in a table. And for this reason, the calculated column can only operate over columns that exist in the same table. For example, if the table has 1,000 rows, it will have 1,000 values in the calculated column. Calculated column values are stored in the Power BI file, and each calculated column will increase the space that is used in that file size and potentially increase the refresh time. Measures are calculated on demand. Power BI calculates the correct value when the user requests it. So when you previously dragged a total sales measure onto a report, Power BI calculated the correct total and displayed that visual. Measures do not add to the overall file size. Measures are calculated based on the filters that are used by the report user, and these filters combine to create this filter context. Ideally, you will create measures as needed, but if you need a persisted column, consider using a column in Power Query before choosing a calculated column for model optimization. Although that's not to say calculated columns are invaluable, but use them sparingly. Lastly, we have calculated tables, which are created like a calculated column. In a calculated table, it's created by pulling data already from your model, and unlike most other tables, which are imported from external sources. It allows you to create custom tables based on DAX expressions. You use calculated tables when you need to generate tables dynamically, like date tables or custom hierarchies, or for creating relationships, like organizing your data. Calculated tables are connected to other tables in your model and are recalculated during a model refresh. Let me show you an example of building all of these three components from scratch. Let's start with a table. So I'm just going to show you there's two different ways you can go about this. So the first one is if I jump into my model view, I can enter data, and this enter data is similar to creating this new table. But let me just click this new table, and what you will find is that it will open up the DAX query expression where I can fill in this information. Now, when I use this table, what I can do is I can then just put in some form of command. So in this situation, I'm going to put in a table where it will create some values and just generate a value from 1 to 30 using the DAX expression, and then give the column name of quantity based on this value that is generated. So if I use this and I click the enter, what you will find is on the right-hand side where we see the data, we will now have a little image which tells me that this table was created using DAX. And if I jump into the data view, I can actually see the output of this value. I have a column named quantity, which has generated values from 1 to 30. That's just an example of creating a table. Let's now also jump into our measures, because measures can be slightly more complex. Inside of our measures, what we can do is we can just set up a value inside of my dimension table. So we have this table created. What I'm actually going to do is I'm going to create a new table, but I'm going to put in data that isn't completely correct. And the reason I'm going to create this is more for organization purposes. So I'm going to put this in, and it's not going to be the happiest of values because I'm just using random column names. If I press this enter value, you will find that it tells me there's an error. And what I'm actually going to do with this is I'm going to rename this table to a measures table. So all of my measures will now belong inside of this table. And inside of this column is now going to be hidden. So I'm going to hide this in report view. And what I'm now going to do is put in my measures based on this specific table. So let me now add, I'm going to go to my table, right click and add a new measure. And what I'm going to do inside of this measure is I'm going to say, hey, let's just take the row count. It's quite easy for our specific data set. And I'll just jump into that in just a minute. But I'm going to say, hey, I want to count the number of rows that exists inside of this data set. And I want to use the fact table that I have available to me. That's an example of just a measure. But when I click on this measure, right, so this measure up here, this row count temperature value, there's no errors associated to it, but it doesn't exist as a table. It exists inside of this measure value that I have here. But if I try to jump into the actual table view, there's nothing there. So it is not stored systematically. But let's jump into my report view, and I just pick this value. I'm just going to check this box, and what's going to happen is it will load the number of rows. We can confirm this inside of our data view. So let me jump back into my data view, and I jump into that probe table. Let's just select this temperature value, and you will see in total, there is 38 rows shown on the screen. You can make your DAX queries as complex as you want. For instance, I can combine queries, I can combine different kinds of code together to create more complicated queries, to make it more complex depending on my use case. So again, I'm combining multiple functions in my example, which will do the exact same thing. So when I do that, and I drag it across, you will see that I can essentially call upon this data set on its own. And in this situation, what it's doing is it's filtering based on if I'm not mistaken, a specific country. Let's just double check that. Yes, on a specific country based on my geography data. Now, one thing that you will find when it comes to working with your data is that you will see these little summarizations. And what this means is that you can actually, if it understands that there's going to be data involved with it, you can say, hey, when I want to start doing my visualizations, I can actually create these implicit models. So this is an example of implicit measures. This is an example of an explicit measure because I'm saying, hey, I want this specific thing to happen. But built into Power BI are implicit measures where I can go, hey, let me just take this specific data set, which now contains the sum, and I actually don't want to use the sum. I want to use, for instance, the count. And I can take the count of it. And this is an example of an implicit measure being utilized. And if I wanted to take this one step further, I could even take some form of filtering tool using the slicer. Not entirely in the same image, but let me just put in a slicer once more. Here we go. And I'm going to put in the country of the data that I'm dealing with, the geography. So similar to, I'm creating this one completely from scratch. Country is going to be Sweden. And if I do that, minimizes to 20. This is exactly the same kind of command. This one, the one you see currently highlighted is using an explicit function, which is one I created myself within DAX. And you have the implicit measure, which is one where you can use just from a visual experience. There's another way of creating measures. Maybe you've been quick to spot it. You may have gone, hey, Victoria, what does this mean? Inside of this quick measure, if I click this button, you can actually use it, create explicit measures using just buttons. You can just click the buttons and find the right value. So again, there are some inbuilt functions that you have available, common DAX queries that I have. So for instance, let's just again take the count per this country. So filtered value, I want to do this. I want to take the base. Again, just taking the Celsius degrees to keep everything consistent in my data table. And rather than taking the sum, we want to take the count. And I can also filter it based on the geography, country. And when I'm ready with that, I just need to select the value that I have, again being Sweden, click the add, and what do you know? A new value gets generated inside of my table. If I press the enter button, I can even drag this into my dataset. Again, different way of working with values. So this is an example of working with measures. One last thing I'd like to point out to you is we just used a quick measure. There's also the ability to work with large language models. So I can jump into tools like Copilot, which will provide a suggestion based on the values. To conclude, each approach serves a specific purpose, and understanding when to use them is crucial for effective Power BI modeling. The documentation will guide you here, but for now, you should understand that measures are aggregated dynamic formulas which are computed on the fly. Calculated columns are row-level computations that get stored in memory, and calculated tables are custom tables based on DAX expression. Now that you have a basic understanding of these three different techniques, it's time to put your knowledge into practice. I want you to create a measure, a calculated column, and a calculated table using a DAX expression. A solid understanding of how context works in Power BI is important if you plan on becoming a good DAX developer. Let's talk about the theory behind rows and filter contexts. A context is a lens that you can adjust when defining how a formula is calculated. In DAX, there are two different types of contexts, the filter context and the row context. You can actually transition back and forth depending on the formula that you create. When I first started diving into the theory, I had a bit of trouble digesting this concept. So let me explain what helped me. Imagine you have a big box filled with Lego. You have green, blue, red, yellow, black, and white Lego pieces. And each block represents a piece of information. Using the different Lego blocks, you'll build a standard pyramid, and now that your task will be evaluating how you went about building it. The first approach says, great job. Now wear these pair of glasses. It will only show you certain blocks. Pick a color now. The glasses will then filter out the unnecessary colors, and the colors of the Lego blocks that you didn't mention will completely disappear from view. So the outcome is that you can only focus on the color that you chose within the entire pyramid. And this is what a filter context does. The second approach asks you to dismantle the pyramid one block at a time. As you remove each block, you are focusing on just that singular block. Where did you place it? What color did you use? What are the neighboring blocks looking like? It's like a mini world where only that block exists. And this is your row context. It zooms in on those individual pieces to explain how it fits within its own context. The filter context helps you see the bigger picture. It takes the whole table, but then highlights specific rows based on the filters that you set. A filter context represents the set of filters currently active on the semantic model during the calculation of a DAX expression, much like a pivot table. These filters can then be applied through slices, visual interactions, or other context-altering actions. The row context tells DAX which row to use when it needs to obtain the value of a column. It does so row by row. It exists within an active iteration, such as a single row of a table, and because of this, the fun fact is that measures do not usually have a row context. Given a choice among millions of rows, which one is a DAX engine supposed to choose? Thus, it is only really applied during the creation of a calculated column. So, you can see that working intimately with the filter context will get you further. And why is understanding the filter context important? Well, filters are almost always present during the calculation of a DAX formula, and they will affect the results. So by understanding the filter context, you can better predict and control the behavior of your DAX formulas. For instance, you can understand how it works And you can now focus on how the filter context travels between a bidirectional or single relationship. You can even determine which relationship to use. That filter context will operate at a model level, so it will travel through all of the tables based on the direction that you determine. With Power BI, even though a measure was only defined once, it can be used in these visuals within different approaches. Each of the totals is accurate and performs quickly. It is the context of how the DAX measure is used to calculate these totals accurately. Let's showcase the important DAX functions you should be starting out with. I'm going to introduce you to the needed nines and then layer it with semi-additive measures and time intelligence functions. In front of you are the 9 DAX functions I would recommend that will help you kickstart your DAX journey. Sum takes all of the numbers in a singular column or expressions and uses it to make basic calculations like totals and subtotals. Sum also represents to me other aggregate functions like average, min, max, mode, median, rank, and more. SumX can take any table or table function as the input, and then it gets used in combination with filtering to create more complex expressions such as ignoring filter context or calculating percentages. It's powerful, but note, as an iterative function, it tends to be more compute intensive. SumX to me also represents other aggregate functions, but combined with this iterative approach. If is a conditional statement and is part of the logical statements branch. It can be used across the different modeling approaches, measures, calculated columns, tables. The if function is highly versatile and why I include it into the needed nines. Then you have count rows and other count related functions, and these will support you in, well, counting the number of rows in a table or filtered tables. Some of these functions include or exclude our blank and empty rows, so return to the documentation when needed just to check your use case. Calculate and calculate table triggers context transitions, which makes it very powerful as a function when used in combination with other functions. Context transitions transforms any existing row context into an equivalent filter context, either by overriding or combining it with existing filters. This override choice depends on the use of the keep filters function and other modifiers. It's quite a quirky function with specific nuances, and sometimes the alternative could be just to combine a filter paired with an aggregate function like SumX to get the same response. Calendar auto and other time intelligence functions allows you to play with time. This specific function will create a date column based on other date columns mentioned in the semantic model. It's a simple shortcut to the calendar function. And speaking of time intelligent functions, date add tends to be the building block that results in many time intelligent shortcuts like same period last year, previous month, last date, and other functions. It shifts back and forth between the selection of dates. Then we have the related and its companion related tables, which allows you to reference relationships to a given row of your analysis based on the same many-to-one direction. Just be sure to make sure that the storage modes can sometimes cause a blocker, and that's where this related table comes in, just to support it in the context transitions. Then we have our selected values and associated values functions, which allows you to retrieve the data input. For selected values, it returns a single value from a column, assuming there's only one value in that current filter context, and it's really good when paired with dynamic conditional statements that include parameters. The needed nines are just a few functions that can help kickstart your DAX journey. DAX is a programming language, and so there will be multiple ways to reach the same solution. You can stack functions, use them in parallel when designing your analysis, and then optimize them further. Just be aware that there are considerations like storage mode type or data modeling approaches for many functions, and these are further detailed inside of the documentation. As I mentioned, you can build upon your queries, embedding functions into functions, like combining your calculate functions with your sum to filter on a specific category and perform other forms of calculations. DAX queries can also support in role-playing dimensions, where if I use the use relationship function, I can declare which relationships to work from, especially if you find yourselves in tables that contain multiple dates. And if you find yourself working with time variables, just know that you can build upon measures and functions that are calculated across a singular value, rather than aggregating it across all of the dates. This is referred to as semi-additive measures, as is shown in the example in front of you. I do want to take a bit of a detour here and explain that Microsoft has implemented AI in many of the services scattered across the Azure platform, and Power BI is no exception. It comes built in with its own copilot that can help you design reports if DAX isn't internalized yet for you. But there's also large language models like Bing GPT and ChatGPT, but just ensure that you provide a sample context for it to work with. More hardcore users will default to their usual channels found in documentations, tutorials from external vendors, and also help forums. In this video, we explored some DAX functions that can support you in your workflow. My advice is that if you want to become an expert in DAX, you should focus on building a library of useful examples. It's an iterative process. My library started with the needed 9s and has since expanded. There's plenty of help out there, and you can dive into it when you're ready. So take a leap of faith and trust yourself that you can do it. Like in any programming language, the more you work with it, the more familiar you will become, and the concepts and implementations will sink in much easier. So here's my next challenge. Using a data set that you're familiar with, take a column that contains a date type and use one-time intelligence functions paired with one of these needed 9 functions. What are you going to explore? After you get comfortable working with building your reports inside of Power BI, you may be faced with performance issues. You can optimize your solution at different architectural layers. At the data source, the semantic model, visualizations, which include your dashboards, your Power BI reports, and paginated reports, the environment. This thing also includes your capacities, your data gateways, and your network. Of course, we won't touch on all of these areas too deeply, but I would like to introduce you to the performance analyzer that can help you troubleshoot when to investigate first. Let's dive into the troubleshooting tool built into Power BI Desktop, the Performance Analyzer. The Performance Analyzer helps you optimize at 2 of the 4 architectural levels, the data model and the report visuals. It can be found inside of the Optimize ribbon within your report. And before you run your Performance Analyzer, you should ensure that you clear the visual cache as well as the data engine cache. Otherwise, the results will not be accurate. Also, you should set up the report so that it will always open on a blank page. You click the Start button, as shown in front of you, and the Performance Analyzer displays and records logs that measures how each of your report elements will perform when a user interacts with them. You can also see which aspects of their performance are most or least resource intensive. And you can immediately see results, make changes, run the analyzer again, and see the impact of the changes that you've made. After you start recording, it takes actions within the report. For example, you can move from one report to the next, from one slicer item, or interact with any of your visuals. Any actions you take in the report are displayed and logged in real time in the Performance Analyzer pane. This is shown in the order that the visual is loaded via the Power BI engine. And by looking closely at the durations in the logs, you can identify which elements of the report are the most or least resource intensive. You can find where the bottlenecks are, and this gives you a good starting point for making those changes. For good practice, you should run the Performance Analyzer, clearing the cache 3 times. And this will give you an average to see if it's something your users regularly experience or if it's just a one-off. Let me show you how you can interpret the results from a Performance Analyzer. inside of my Power BI environment, I'm going to navigate to my Optimize. I'm going to select my Performance Analyzer button, and then I will click this Start Recording option. This is the Performance Analyzer pane, by the way. So when I click this button, I can navigate through my tables and I can click specific values. I can work across the data set. And as I said, navigate from my report environments as well. And when I'm done, all I have to do is simply stop the Power Performance Analyzer and then take a look at what was recorded. So if I zoom in on this specific environment, you can see all of the values that I clicked and all of those kinds of actions that took place. Now, what I can do is determine how these look. So let me just click this DQ profit and country group because it seems to have taken a little bit of time. And when I click on this value, what you will find is that there was a DAX query, a direct query that took place. So I know what the storage mode has taken value. There's a visual display, which didn't seem to take that much time, only 14 milliseconds, and some other environments like the network that takes place. In total, this took 3,282 milliseconds, so 3 seconds in value. And what you will find is that it will show you the cumulative total of everything. So the direct query ran, then on top of what the DAX query completed that direct query. So in total, that was around the 3-second mark, and then it applied it to the visual display and others. So how I could interpret that is that this direct query is the result of a potential bottleneck in comparison to, for instance, my import values, which seem to produce values at 1/6 of the total. So what I can do with this is I can analyze my query plans for optimization opportunities. If you notice that DAX is the cause, then it's time to start diving into your measures and custom calculations. You should be troubleshooting which part of your query is the root cause, and this is where variables can come in to help you. Not only do they support in keeping your code nice and clean by reducing the complexity, but they also increase readability. This allows you to experiment with certain functions over others. So here we see that the DAX value is taking approximately 3 seconds to load. And if I break up the functions into variables, I can then take it to external plugins like DAX Studio and evaluate the query and performance. For instance, I identified the problem here being the filter, and I replaced it with this function called keep filters. And when I ran it again in the performance analyzer, again, making sure I clean my cache, it was much quicker. Let me just show you that. So you can see that by experimenting with just functions, DAX offers the ability to make speed performances, resulting in a significantly lower time and latency in loading those visuals. Variables made it easier for me to troubleshoot because all I had to do was change one location instead of diving into and deconstructing the code. Other things that you can look at will be to optimize your report may depend on the source. And the source is very important because the way you optimize an import semantic model will be very different from optimizing a direct query semantic model. So check the documentation for some of these steps. For instance, maybe it will be suggesting aggregating your larger data tables where possible, reducing cardinality, and from a reporting side, you can further increase performance by reducing the number of visuals on a page and elements within that singular visual. In this video, we showed you how to optimize Power BI performance using the Performance Analyzer, including how to troubleshoot and improve the performance of your DAX queries and report visuals. If you have a report with visualizations, try running the Performance Analyzer yourself and see if you can interpret the values. What can you tell me? If you're diving into the world of DAX, data analysis expressions, for the first time, fret not. This video is going to dive into some of the strategies to make your experience more engaging and approachable. First, you need to worry about the important functions. There's a lot to dive into. Some functions are optimized versions of other functions, and it can create the feeling of discomfort. You may suddenly freeze of, I don't even know where to start. And then you just don't. And that's when you start to miss out. So here's my advice. Focus on working with functions like sum, SumX, if, count rows, calculate, calendar auto, date add, relate, and selected values. Next, don't focus on memorizing your DAX, focus on creating the templates. We have Copilot, large language models, documentations, tutorials, especially tutorials coming from external vendors. We have help forums to support you. Instead, focus on building a library of useful examples and expect that you won't become an expert immediately, but iteratively. The more you work with it, like in any programming language, the more familiar you will become with the concepts and implementation surrounding the syntax. As you gain familiarity with DAX patterns, in the library of useful examples, also start building a mental template to categorize across the different types of calculated measures you can build. For example, you can group them through a simple aggregation where I play with the average X, a business-specific calculation, year-on-year percentages, time variances, and more. This way, you'll have a rough outline to build upon, saving a lot of time and effort in your projects. If you don't need it, delete it or hide it. And this applies to your objects, your columns, your measures, your tables. Wherever possible, you should be using explicit measures and ensure that these columns are renamed to user-friendly names. This will allow you to focus in on what is needed, set up areas for your measures, and reduce taking up space that could be utilized more effectively elsewhere in your report. One thing I do have here is that there's a table in Power BI that contains all of my measures, and it's easier to navigate through my report and help me with correct labeling to understand what that function means. Focus on building readable code. DAX often involves complex calculations on a single line, and keep your code readable by deleting these unnecessary elements using descriptive names, variables, and just being explicit with your references. Variables can help troubleshoot problems as well as reduce the amount of copying and pasting needed. It's easier to map out complexity, and future you will thank you when you need to return to that project 6 months down the line. To conclude what was discussed, the focus should not be on learning everything at once, but cherry pick what is important to your situation. Look at your examples online, build your library of commands that you can always fall back on. Keep it clean means that it's easier to remember and identify relevant commands. And lastly, keep your reports clean by coming up with suitable naming conventions. And ideally, focus on creating measures over calculated columns. It's time to talk about security inside of Power BI. In Power BI, you can secure reports and workspaces by sharing them to a Microsoft Entra user or a group. It is also possible to share a single report, but have the user see different data according to their job role or description. There are 2 ways you can implement row-level security, or RLS, in Power BI, through the static method and the dynamic method. Row-level security uses a DAX filter as its core logic mechanism, and we're going to discuss how you can implement RLS in Power BI using DAX to ensure that only the appropriate person is seeing the appropriate records. The steps require you to be inside of your Power BI desktop environment. You're going to be creating your RLS role using DAX or the GUI approach. You're going to then test this role and publish the report. Just note that the security restrictions will only apply to a viewer role. So I'm inside of my Power BI desktop environment, and the thing that you want to be paying attention to when it comes to working with row-level security is this Manage Roles and View As sections. The Manage Role section is where you can define your DAX queries and set up your row-level security, and the View As is for you to test that specific role. So inside of the specific data set, you will notice that I have set up a dimension table that is referred to as a security group. Let's just quickly take a look at it because it's actually connected to this location structure. So when you have a set of users, for instance, I have this email and a specific state that they're attached to, it means that I can then set up some filter controls. And I recommend if you go down the security group approach, that it becomes a single cross-filter direction. Now, let's talk a little bit about this manage roles. There are two different types of ways we can work with the data. I already have one that's existing, but we'll jump back into that later. Let's create a new one, and we're going to create one that is going to be a static row level security. So I'm just going to call this static. And what we're going to be doing is we're going to be filtering it based on the location equaling Texas. So what I need to do is I've created the role. Now all I need to do is select the location. So if I take the security group, I can then add when, let me switch to the editor, when state equals Texas. And that is how you go about setting up a static. But bear in mind that if I had hundreds, thousands of cities inside of here, that's going to be a lot of work. So what I can also do is I can switch to a more dynamic approach. And inside of this, I can add a specific user. So again, choosing my security group, I can then say the user will equal a specific DAX function. And the magic DAX function here is the user principal name. And when I use this specific function, what it's basically saying is I want Power BI to check the email address that is associated, that is signed into the Power BI environment. And if they meet a specific group or a specific user, then they're allowed to be in. Otherwise, they can't see the specific row that you want. And again, this will apply to a user role. So when I do that, all I have to do is, save it. Well, let me just rename it. I think that'll be a nice one. Dynamic, and I'm going to call it simple. So when you've done your specific roles and you've customized it to what you need, you can simply just save the security roles itself. And what it will do is, I can now close it down. I've been given permission to do so, is I can now test it as a specific user. So let me just use this static row level security where I can go, all right, if this user is from Texas, they should be restricted to only Texas-related cities, right? So Houston, Irving, Katy, so this specific user can only see the data that is coming in from Texas itself. And once you've made sure that everything is exactly as you expect it, you will then publish your report, and this will make the changes inside of your Power BI service environment. So there you have it. An example where you can play around with your DAX filters in a static and dynamic approach. We explored row-level security. Row-level security allows you to restrict access at a row level, so it filters it out to users viewing a report based on the permissions given to them. You can build your row-level security statically or dynamically, and there's a few best practices like using a user principal name function over the username function. And I'd suggest you take some time to explore how to go about implementing row-level security and the best practices that come with using these approaches. Learn anytime, anywhere. I'll see you soon. Hi, I'm Victoria, and I'm joyful that you could join me today. At this point in the data journey, our foundations have been built. We've created a semantic model, and now it's time to add some visual flair to our insights. It's what we've been looking forward towards, right? Visualizations and reports are where the magic happens. Our data transforms into meaningful stories that resonates with our audience. Picture this. You're standing at the edge of a vast data landscape, armed with charts, graphs, and interactive dashboards. As you dive into your visualization pool, trends emerge, outliers wink at you, and patterns unfold. As data analysts, we wield this baton of customization, fine-tuning our visualizations to perfection. maybe that bar chart needs a touch of gradient, or perhaps that scatter plot craves a hint of animation. It's like adjusting the focus on a camera lens. Subtle tweaks that elevate the entire experience. Now, let's talk about audience. Like any audience, they have diverse tastes, which means they will expect reports to match their needs and requirements. For instance, executives will want the big picture. They'll be drawn to dashboards, clean, concise, and packed with KPIs. They're not interested in the nitty-gritty. They want a helicopter view, so we serve up sleek visual summaries that fit their C-suite sensibilities. Analysts are the data detectives. They love digging deep, unearthing buried insights. And for them, analytic reports are like treasure maps. Give them a detailed breakdown, trends, analyses, and correlation matrices, and they'll know where to take the next move. Then we have our information workers who use operational reports as their tools. This includes daily logs, performance metrics, and process snapshots. Think of it as data carpentry. They need sturdy, functional visuals that guide their decisions and keep the gears turning smoothly. And lastly, the general public. Those curious souls. They're hungry for knowledge, but not necessarily data savvy. Educational reports are their textbooks, so we need to make them engaging, approachable, and, dare I say, fun. We approach this through infographics, storytelling, and relatable examples. And here's the secret sauce. Design thinking. Each report type deserves a tailored approach. Executives get elegant, minimalistic, and impactful reports. Analysts dive into precise, data-rich, and informative reports. Information workers add the dashboards to their utility belts. It becomes practical, actionable, and efficient. And the general public? Well, they're after information that is friendly, relatable, and enlightening. This next section jumps into how we can design effective reports by creating visuals and some of the features that allow you to make the most out of your Power BI user interface. Your report users will rely on visualizations as a gateway to the underlying data. Thus, it's important to create a report that incorporates effective visuals that really complements the ability to tell a compelling story. Let's break down what it means to create an effective visual. When I talk about an effective visual, it's breathing life to your data. And what I mean by this is you're bringing clarity, accuracy, and relevance that makes a user go, yeah, I understand what you wanted this information to tell me. Let me do something with it. That's how you create impact. In Power BI Desktop, our data story and visuals are represented by an icon, and this can be found in the Home or Insert pane. The Power BI tool changes all the time, so the layout can be different to what you may see throughout these videos. But what you're ultimately looking for are the icons. These icons show you out-of-the-box visuals, ranging from your bar charts and other various charts, filtering tools, tables, spatial tools, and card icons, just to name a few. You can have Power BI suggest a type of visualization too once you start working with the data. And if your organization permits it, there's also a marketplace for visuals that allow you to import third-party and custom-designed visuals as well. What I want to tell you now is that the same kind of visual can be used across different use cases. A visual can enhance or detract away from your data story. So choosing and then designing them is what makes or breaks an effective report. Going into specifics is quite complicated because it will depend on your narrative. So this is why I focus on the use cases and recommended visualization tools inside of Power BI. Let's talk about these use cases, which are in front of you. There are 11 in total. Comparison visuals explore comparing the numbers between categories. It provides a side-by-side comparison, allowing you to say, Category A is larger than Category B based on measure X. In Power BI, clustered bar charts tend to be the preferred method here, but you can choose tables, word clouds, dot plots, or bubble charts, just to name a few. Data over time visuals spot trends, explore rates of change, and track these changes of data over a time window, allowing you to say, situation B has grown from time window A to B. But it had a sudden decline at time window C. An example could be sales performance over time. And in Power BI, line charts are the preferred method here, but you have forecasting options, ribbon charts, KPI measures, and more. Correlation visuals are used to describe the relationship between two data points. An example could be exploring a person watching this video and the number of Power BI Analyst exam registrations. We could use it to identify clues in patterns. And if you can connect the dots and see a pattern, then it's likely there's a connection and you can draw a correlation. Although, be careful because any person with a statistical background will tell you correlation does not equal causation. In Power BI, scatter charts are useful here, and further third-party sources can enhance your exploration further. The key influence of visuals is also a handy tool, especially when identifying these connections. Distribution visuals show how often values occur in a dataset. You may have come across histograms or explored skews in your datasets, and this allows you to identify data concentrations. You can explore how the data points are spread out to understand the data distribution. In Power BI, clustered column charts, histograms, box and whisker plots are all good starting points to explore your data distribution. Part to whole visuals help explore the proportions, contributions, or percentages based on our datasets. We're breaking down elements contributing to a whole. For instance, how the products in a product category contribute to the total profit. Power BI recommends that bar or column charts tend to be preferred over our donut and pie charts due to the clarity, ease of comparison, as well as accurate representation of these absolute values. That doesn't mean they aren't included, but alternative approaches could also include tree maps, waterfall charts, or waffle charts. Ranking visuals are used to convey information about the importance of items. It's displayed ordered lists based on a set of criteria, for instance, ranking a city based on the number of orders that could influence where it ends up in the next store location. Power BI recommends that you stick to clustered column charts, matrices, and tables, and if hierarchical ranking is needed, then I'd recommend Sankey diagrams. Filter visuals allow you to display specific subsets of your data based on certain criteria. They help you focus on what's most relevant, and you could filter your report based on a time window or category that makes sense to your business needs. Power BI recommends slicers, which can allow a user to customize a report to their needs. You can also control filtering through drill-throughs and at a visualization level, page level, or report level. Spatial visuals represent data in the context of geographical locations. They allow you to visualize patterns, relationships, and trends based on where things are located on Earth. And once we build a moon base, the moon too. In Power BI, the standard map tends to be a good overview, and you can utilize field maps, synoptic maps, work with the ArcGIS maps, and more for your spatial visualization needs. Flow visuals allow you to display flow or dynamic relationships across the various dimensions in your dataset. In Power BI, waterfall charts and funnels are great starting points. Waterfalls are useful to see a running total, to see how an initial value is affected by a series of positive and negative changes, like exploring profit and loss over time. Funnel charts visualize a linear process with sequential connected stages where items flow sequentially from one stage to the next, like exploring success rates or churn rates. Sankey charts, decision trees, and decomposition trees are also good options to consider. Single visualizations allow you to convey essential insights effectively. It's eye-catching and usually allows a user to track an important statistic like the total value or year-over-year change. In Power BI, we have our cards, KPIs, and gorge charts. Tables, multi-rows, and others are also some key considerations you can take. Narrative visuals provide descriptions based on the data. It can be used to support the storytelling by providing a summary or generation of an answer using more data. In Power BI, we have our Q&A and smart narrative tools, and these can facilitate a more detailed dive into the data. Now, let's say you don't get it right the first time. You can always change it, and I'd like to share a snippet of a recent discussion between my colleagues Linda Larkin and Andrew Conniff regarding building effective visuals. Let's hear what they have to say.
We can go in, and while the visual is selected, we can actually change the visualization type. So it's very easy to grab the data that we want,
right,
put it into a line chart or an area chart, and go back and forth between them, and use our own impressions on whether one is going to be better than the other.
Right. So it's forgiving if we create a visual and then we decide, I really should have done an area chart instead of a line chart. It's just a matter of clicking a command. Right?
Yes. Yeah. Now, some of our more advanced visualizations, we may have to do some additional input, but for the most part, that's going to work that way.
I think they've summed it up nicely. The visuals are forgiving, which means it's not the end of the world if you don't get it right the first time. The design phase of your report should be very experimental and iterative. It's also nice because you can change your mind at any point and not suffer crazy repercussions. For those moments where you're feeling unsure, I usually create an appendix report page, and that allows me to save those visuals to go back and compare upon. And once I've chosen my final layout for the entire report, I just delete that page as it served its purpose. Building effective visuals can be done in a variety of ways and will depend on your use case. It's not a one visual fits all kind of situation. Power BI will try to support you in providing recommendations, but after all, you are the architect here, and I am confident that you will find a great solution that is able to tell a compelling story. I want to give you a bonus challenge here. I want you to take a data set that you're comfortable with. Just pick one of the categories and just experiment with the different types of visuals available to you. When you find the right graphic, we can then start to think about how we can then improve on just that one visual. The types of use cases can influence how you choose your visuals. Let's show a quick example of how I would go about creating an effective visual inside of Power BI. So Alice sent me her report and she asked me what kinds of improvements I could make to make it more effective to her audience. I'm going to address it from the perspective of choosing a singular effective visual. So let's just pick one of them from our list and work with it inside of our new window. All right. So here is the report in front of you, and my eyes are particularly being drawn to this eyesore. So let's first understand what Alice wanted to achieve here. So I'm going to zoom in just a little bit and scroll down. So in front of me, I see that we have some form of date on the x-axis, and it's been separated by quarters. We have some form of total orders made based on the employee. So I think what Alice wanted to go down here was to track how each individual employee was making those sales. But when I look at this, it's quite hard to really see their overall contribution over time. So what I think we should do is work with a singular person and see how we can improve the journey of a user through the environment. Now, if I think to my use case, it's the combination of we are comparing different kinds of employees across time. So it's going to be this comparison paired with this date over time visual. And Alice went for a stacked bar chart. But you know what I'm really thinking here? I'm thinking it should be the combination of a bar chart paired with this time series. And the first thing that comes to my mind here is a ribbon chart. This over here. So what I'm going to do is I'm going to just take this specific report and I'm going to put it inside of this section here. Oh, edited already as we go. And put it down as we go. So the thing I want to make sure about this specific visual is I want to play around with the format. So I can either right click and click this format option, or I can jump into my panel here where I can bring it up. And what you'll find with this format is there's quite a lot you can do to experiment with it and play around with this specific visual. So let me also, this is the before, and now let's do the after as well. There we go. Okay, so what we're going to be doing is the first thing I'm going to say is I noticed there is a little bit of a background in the image. So let me just jump into the size and style and just either turn the background off or make it white. So in any reports that I deal with, it will always have a white background. I'm also going to take this title here and just adjust it to the middle. So let me just find the title and find it in the formatting sections to middle. So now it's a little bit more centered and aligned appropriately. I'm thinking also that I could change the background color. And so bear with me here. It might look a little bit rough at first. Let's just choose this color. And then we can now change the main color to white. So it just looks a little bit more like it's meant to be there. It's meant to have a specific pace. So now that I've set up the main part of this, I'm going to put in a ribbon chart. And what you will find is it stays, the format changes that you work with inside of these charts will change. So now what I can do is I can follow along the story of Margaret, right? So I can say Margaret increased her overall sales in Q4, which then dropped in Q1 to increase again. And her highest performing sale was in this Q1 in the later part of 1998. So that's the first thing I can do. And maybe what I might want to do is experiment with this. And something that you can do inside of the ribbon feature is play around with transparency. So let's just see if we can find transparency in my text. There it is. There's background, transparency, and ribbons. There we go. I want to go to this ribbon section here. So the transparency is at 30. I just want to increase that just a little bit more to about here looks about nice. You know, you can experiment, you can play around with it just to see what works best for you and what you think works best for your users. The other thing I want to do inside of this ribbon, so let me just get rid of this, inside of this ribbon pane, is I want to create a little bit of distance between these specific columns. So again, inside of this ribbon approach, I believe inside of the layout, I can just increase this. And I don't think it needs much because it does actually look quite nice. And you'll see these little white spaces appear in between the graph. Let me just make this very apparent and obvious to you. See? All right, but that looks a little bit clunky. So let's just go back to 5. 5 seems like a good value just to allow the user to go, right, this is the main point in this specific time point. So now we have this ribbon, it might be nice to know what exactly is inside of this data. And I think what would be useful here is this data labels. So I'm going to turn them on. And as you can see, only the bigger values that are more visible will become more apparent. If I zoomed in, I would see far more options available to me. If I zoomed out, only the highest numbers would show the specific values. All right, let me just return back to my graph and zoom out just a little bit. There we go. Okay, so now what I can do is start thinking about the overall layout. So my ribbon chart is pretty much, I think that's pretty much complete for this specific time. And what I can do is I can jump down onto thinking the legends might be nice to play with. So we have the legends. I want to keep them, but maybe I just want to change the position. So as you can see, it is you just click, you drag and drop. And now, as you can see, I can follow the story of, let's do Margaret. Margaret's my chosen person. So I can follow the story of Margaret based on the total number of sales she made over a quarter period. I just double clicked to bring me back into the main report. Now, I think we're pretty much done here, but I want to show you something as well because this report allows me to do it, and it's the concept of working with drill-throughs. So we have, for instance, time, and time can be broken down into years, months, days, weeks, right? And what you can do is play around with hierarchies. And if you look on the top of any graph or visual that you have and you set up some form of hierarchy, you can actually navigate your way through it. So this is year, and if I scroll down, this is the quarter. If I scroll down again, this is the month. And as you can see that the image will change based on your use case. Now, one thing I really like about this specific image is that I can drill down onto one specific hierarchy, which allows me to say, all right, I can choose the best image available. And you can see within this hierarchy that it's broken up into this date column, year, quarter, month, which allows me to navigate. Let's just take a little bit of a detour though when we talk a little bit about hierarchies, because the way you make them is actually relatively easy. When you are building your models, so in my data, when you're building your models, all you have to do is select inside of the table that you want and create a hierarchy, and then you can then drag and drop your items into this hierarchy. So by default, if Power BI knows that there is a known hierarchy between items that exists like date, then it will naturally incorporate that. But you can also create your manual hierarchies too by just right-clicking and creating a new hierarchy within that specified table. And this allows you to then bring it into the report at a later point as its own variable. So there you have it, an example that explored how we choose an effective visual. Building an effective visual is about knowing that it's not just about what is presented, but how it's presented. And we used the format tool to play around with the background color, the size, the style, the title, the legends. It all depends on the visual icon you choose. Even our tables can experience conditional formatting as well inside of these formatting panels. And you also have the ability to explore potential hierarchies at various granularities. It's time for you to tinker on your own reports. So choose one of the visuals that you plan to work on and really dive into its purpose. What's the intent? How can I make it look better? I look forward to seeing what you can come up with and diving into them within our community channels. Some reports look good and some reports look terrible. Why is that? When it comes to designing your reports, you need to start thinking about the visuals you want to build and also approach your report from the perspective of your target audience. Visuals are important. They capture your attention and can help you grasp patterns and trends much faster than if you looked at tabular data. But I'm sure you're aware of that. Let's use this video to talk a little bit about how we can go about designing an appealing report. Alice sent me a report a while back and she asked me for some feedback regarding it. In front of you is what this report looks like. I want you to pause this video and take a closer look at it. What are the things that look wrong with it? What are the things that stand out to you that can be improved? So let me just take this report, and what I've done is I've embedded it into a whiteboard because we're going to annotate it. And I'm hoping you've also come up with your own ideas as to what can happen. Now, the first thing I want to say that Alice did good was that she separated her main important information at the top, and she's made it interactive. So a user knows that if they wanted to interact with this report, they could, right? So this is the interactive side of that specific environment, and these are the main headers. Now, when I look at this report as well, I can see that she's also broken down the report into 4 areas. So we have this kind of visual environment. And it's not necessarily a bad thing. I think actually the number of visuals she's put in here is useful for her use case. We can see that she wants them to know about their total sales and the number of orders, the profits, and different values. But the problem that I'm finding is that this report is just a little bit too much on the eyes. There's a lot of things that can happen. So for instance, I'm looking at this background color, like this gray background color, and then we have this blue background color. And I'm just going to be, in my head, I'm just going, it's a little bit too much. So the thing I would be saying as a critique is that she needs to address the background. She needs to either choose or work with her company to have a theme environment for it. So background there. And With this background, I would probably just say, let's just go for white for now. If your company doesn't have a theme, just use white. It tends to be a very neutral color. It's quite easy on the eyes. You can also use just a dark color, but just make sure that it's consistent. That's the first thing I want to point out. And when I'm looking at some of these tables, so this one looks a little bit like I don't think it's the right visual. So I'd be circling this and going right visual and putting a question mark. Probably not, because I think that's quite a lot to look at. What does she actually want us to convey? So I'd probably tell her, hey, maybe we just we change that a little bit and try and understand what you wanted to convey here. I have this table. The table's all right, but it's just a lot of text. Something that we could either do is filter this table by a specific amount, but we do have the filters on the left-hand side of the report. So what I might suggest is we can use things like conditional formatting just to make the values that we want to really stand out and really pop in front of us. Now, I also see up here that the values are a little bit like all over the place. Like if I were to draw a line and I try and make this straight, you will find that some of these values are intersecting this line and it's not exactly even. So we might need to think about how we can standardize our values, and maybe we can just pop these out just a little bit more so that they stand out. We can read the title. As you can see, some of these words are just missing completely from the graph view. I actually think we could add like a shape to make this line actually just distinctly say, hey, there's something here. And the same goes for this interactive side of things. Like, okay, I like the fact she's used these filters because it means I can play around with it to my specific needs. But look at it. It's all over the place. It's very quiet. It's moved out of view. It just needs a little bit more attention to detail to make it so that the user knows, actually, if I were to press this button here, it would create a drop-down table. And then I would just clean up, for instance, these headers, again, going along the theme of standardization, right? So it's mostly just about being consistent, being about standardized. The way you can design your reports, by the way, is, for instance, you can design them into sections like this, as Alice has done, something like that, or you can treat your report as like a 3x3 grid. And then each kind of section is supposed to be for something. And the way a user would be reading it would be something like this, where they start from left to right, but again, cultural differences may apply to your specific use case. So let's actually help Alice out a little bit and just show her like some things that she can do straight from the get-go. So I have her report in front of me now. And one thing we're going to just focus on is these little headers up here. I think this is something we can work with quite quickly and just say, hey, let's get this up. Let me just show you what you could do immediately straight from the get-go. I'm also noticing that this should probably have a transparent background, or as I like to do is if I just right-click this and I click this format button, I can immediately change the background to white, right? And that immediately addresses this problem, but you can also do some form of logo change later down the line. And I would also be, for instance, changing the backgrounds of all of these reports to just white for the time being. And at some point, we can come back to this once we are ready to deal with it. Like, let me just turn it off. We can come back to it and just reduce the eyesores and make it a bit more prettier that's in line with the theme that we want to go through. So let's first work with this environment. So I'm thinking, let's play around with these summaries at top. So I'm going to zoom in on the report. And we're going to take this step. Oh, scroll up. We're going to take this step by step with this total sales. So for instance, let's start with this one. Because we changed the background to white, now the text has suddenly disappeared. So what I'm going to do is find the text value. So if I jump into this title value, let's just go here and category label. This is the gray value. This is what's causing it. And I'm thinking, actually, what if we made this a nice blue background? So this will stay white, and then we get this title in the front. We give this a nice little blue background and give this a white text color, because otherwise it's a bit of an eyesore in the environment. And if I grab onto the actual background of this box, I turn this on and I choose the exact same color as previously shown. And what I can do is just move this down into view and get rid of this label here, right? So that immediately in my eyes looks a bit nicer than before. And what I can do is I can then apply the same kind of thing using this format painter to the other values. So they all have the same kind of formatting. It's quite a nice tool if especially you intend to do a lot of repeats in your data set. And what we can then do is start looking at some of the differences here. So I can go, hey, well, these need to all be nice and even. And I can just smooth this out a little bit. This is just 5 minutes of me playing around with it. I'm sure if given enough more time, we can really do something worthwhile with this report. So I'm going to keep this last one. I don't know if that's the most important thing, the last order date, but to Alice, that seems important. So we're going to keep that one colored. This one should be just a little bit shorter, right? So this is an example of just standardizing your report just from the get-go. I think it looks a little bit smoother, a little bit cleaner. And of course, I could take it a bit more in formatting. And I mentioned in my whiteboard that I wanted a straight line. So let me just insert something. And what you will find in Power BI is you are not restricted to just putting visuals, just visualizations of your report icons in there. You can actually create text boxes, buttons, shapes, and images. And I'm just going to add a line, just a small, simple line that exists in my Power BI environment. I'm just going to shorten it a little bit. And what this line will do is act like a break, right? So I'm just saying, at some point, we can come back to this and go, right, keep this nice and smooth and clean it up as we go along. And then they will know that there's a little bit of a break at the top of this report. Yeah. So I think for now, I would give Alice a list of recommendations regarding what we did inside of inside of our little mini case study. Of course, you can add more to this. You can go, oh, Victoria, maybe we could do this thing with it. And I would encourage you to play around with these kinds of elements. One thing that we can do is, one thing that I did was I waited on Alice's. I gave her these feedback to her and I showed her like, okay, maybe we could work with this and we can improve the report. And what Alice did was she came back to me a few days later going, hey, Victoria, I did something. And I looked at the report and it looks brand new, right? It looks much more standardized in the approach. Like we have all of these, which are nice and even. She kept this last order date. So good thing we didn't touch that. And she also added extra colors on the global scale. She standardized how her titles looked. She matched them, for instance. And she even added some of these icons and made the formatting stand out. She played around with the table. And by the way, just so you know, if I were to click one of these tables, the whole table will change and interact depending on that specific table. I think it's quite cool. It's called cross-filtering inside of Power BI. And if we look at the table, she also formatted the table so it had some form of conditional filtering. And that's a really fun practice that you can do inside of your documentation. Well, there you have it. You have an example of how you can critique your existing reports and think about improving it. You can add shapes, text, visuals, play around with cross-filtering. Just remember, it's an iterative process. You may not always get it right the first time, but that's completely okay. Power BI has your back. And truthfully, visualizations aren't my strong point, so I get a lot of inspiration taking part in our Power BI community. These are Power BI users who want to share their knowledge and showcase their skill sets, and I think it's really awesome and would love it for you to one day contribute your own resources. So let me show you the community channel that we have inside of Power BI. Now, inside of this community channel, there's a variety of galleries that you can play with and explore examples, specific use cases, and get a feel for how other users are working inside of Power BI. Now, one thing that I really liked in terms of as an example is the concept of bookmarks. So I talked a little bit about shapes and icons, but there is another value that you can play around with. And in this specific user, this user decided to talk a little bit about climate change being real, and he shared like where he got his data sources from and a Power BI report that you could work with. And inside of this Power BI report, he used this tool called bookmarks. And bookmarks are quite interesting because what they do is they force a user to see a report from a specific perspective. And the way you create them is very simple in terms of adding a button and then declaring it as a bookmark. And it's basically you play around with the report and you just say, I want to take a snapshot at this specific moment. And let me just show you this specific user's example. If I press the control-click value on this button, it takes me to a specific element inside of the report. Of course, I can interact with it. There's nothing wrong with it, but he wanted me to see a specific moment. And I can go back and forth and I can navigate using these icons. And the way he set it up was he created these specific images of what he wanted us to see. And it can be found in our format. So if I open up my format button here and I click on one of these icons that he created, you will see there is an action point waiting. And if I click on this action, you will notice that the type is a bookmark and you're then selecting to a specific value and you just navigate through it. It's kind of like creating a PowerPoint, but with the ability to go through it and really dive into the data itself. So you can preserve your reports using these bookmarks. As I said, it's pretty useful because it forces the user to see the report from a specific viewpoint. And as you configure your report, you let your bookmarks transform the intent into a static image, but much fancier. We discussed how to go through creating a report. We started off discussing how we could enhance our visuals by customizing our report further. Take some time to evaluate a report that you have and use that same critical eye that we worked with inside of Analyst. What can you improve? Navigating a report is the way in which your report users move easily throughout your pages, which can improve accessibility and readability. Let's talk about how we improve our storytelling by incorporating navigation and sorting our reports. Report navigation is the way in which your report users move from one page in your report to the next, move from one visual to another, and they can go back and forth to where they started from. The design of your report navigation is very important because if a user cannot easily find their way around your reports, they will become frustrated and potentially have a negative experience. You can use a range of buttons and bookmarks when designing your report navigation, and you can further enhance this navigation experience with the use of conditional formatting. To design the navigation within your report, you can create a new navigation page in your report, add the navigation buttons there, and you can also use a combination of both options. When users click on one of these buttons, they are brought directly to a different page within this report, which you can then hide, so it can be used and accessed through the navigation page buttons. And when you've set this up, you just copy and paste that button to create the second navigation button. So you preserve that formatting that you've applied to that first button, and then you just change the title and the destination for the second button. Let me just show you this really quickly. So I'm in this report, and in this report, I have multiple pages which I would like my users to navigate through. And what you will find in this report is that there's nothing that I can connect to. So let me just zoom back in, and I'm just going to show you how you can go about inserting it. So the way you can go about inserting a specific navigation is using this button tab. And this is usually found in the insert, but again, depends on your user interface environment. So what I can do is I can use these right arrows, left arrows. What these are basically icons, and you can customize them depending on what is important. So I'm going to just click this right arrow here. And when I click this right arrow, it appears, and I can then, for instance, think about formatting this and setting it up. Well, for now, what I'm going to do is just put it in a specific location, somewhere down here. we can come back and format it when everything is ready or move it into a position that works for us. So let me just click this format button. So when it comes to setting up navigation, there's two things I think might be nice to do here. One, just set up the button style. So I can be like, hey, whenever someone hovers or presses on this, it will show a specific setting for it, and it can show, hey, there may be some form of change that appears. Up to you what you'd like to do here. Now, for creating some form of activity, such as navigation, what you're going to be doing is setting up an action. And if I turn this on, what will happen is I can then determine the action that appears. Oh, it turned itself off. Let me put that back on. So I can say, hey, this is somewhere where it will go to the previous page. Well, it's not going to the previous page. It actually wants to go to the next. So all I have to do is just change the next value or go to the next environment or the next page navigation environment. And I can then click one of the pages inside of my report. So if I do that, problem solved, really. I can set up the title and I can get this ready. So now what I can do is it's telling me to control click the following link. And by doing that, it will set it up. And I can copy and paste this as discussed previously by just Control C, Control V, and it sets itself up. And all I need to do is configure it to the next location. So this is an example. Let me just click you just to demonstrate. This is an example of how you can navigate across it. Of course, if I jump back into one of my buttons that I created, note that you don't have to always do a specific page in this. This could be linking to a specific URL. This could be linking to a specific URL, a Q&A, a bookmark that you've created, which are custom configurations, or towards a specific slicer that you're interested in telling that appropriate narrative. So that's an example of how you can go about building page navigations inside of your reports. You can take this a step further and you can work with conditional formatting, and you set the navigation destination based on the output of a measure. This can help you if you are constricted by your semantic model space, because you can have the report filter based on that user's criteria or through a set of reports. But first, be sure to have the basics down. So we understand that we can navigate how we can explore within a report using these buttons. How do we go through individual elements on a report, and why would we want to be focusing on it? The how is through using selections and ordering of your reports. Selections allow you to determine what items in the report are visible and what items are hidden. Selections are used alongside bookmarks and buttons. So let me just show you a quick example. Please note that depending on your Power BI version, the user's interface may be different. Okay, so inside of my report, what I can do is I can essentially say, how do I want this report to appear? And how do I want this report to appear to a specific user in terms of screen readers, in terms of how they're reported in terms of the canvas? So what's going to happen is I can essentially just determine that. So in this specific user interface, I can click on this icon and I can choose this selection bar. And what this selection bar says is, hey, you can manage how you go about layering your objects within your specific report environment. And if I jump back and I click that little button there, the selection button, you will see one of these filters improves. I'm just going to minimize these other visuals so I have your complete focus on the selection. And what you will find inside of this selection is that there is the name in which things are layered and ordered. And to work with it, all you need to do is drag and drop these buttons or hold and click, right? So you can choose how they are going to look, and you can also choose if they become visual on a report or not based on this little hide button. Again, me doing that completely hides the total sales variance on the report. Let me just zoom out because there was a graph and now there's no longer a graph. Oh, that's not zooming out, that's zooming out. Click this. There you go. See, I can hide or show it. So the layer order reflects how the visualizations are reported on the canvas. So it's the first listed visual in the topmost layer. And the last listed visual is usually shown on the bottom of the layer here. So this little Q&A is the very last one. There's also, if you've noticed, so that's the layer order. There's also the tab order. And tab orders are really good tools because they show how a visual gets read out if a user is using some form of keyboard navigation approach. So this tab would say, hey, this button that's down here is going to be read out first, which doesn't make sense. So let's move that to the last so that the user can interact with it. Let's move it down one more time. Can interact with this value as we go. So the first thing a user would be hearing is the table shown here. Normally, I like to say that the top left corner is where eyes are drawn to first. So what I would be doing is pushing this up one more, right? So you can customize your reports, and this will allow a good sense of accessibility to users and creates an inclusive report environment. Speaking of accessibility, your user interface requirements should also factor in accessibility. Reports need to communicate to the broadest audience possible. So you should consider how to report to consumers with no to low vision or other disabilities so that they can fully experience the report as you want them to. While you may not be aware of a report users with accessibility issues today, it's usually a good idea to design for it straight from the get-go. Accessibility requirements can influence your report designs in terms of the forms, the input methods, as well as the style. For instance, you may want to start thinking about how you go about working with your alternate text and labeling them. We covered how you could go about navigating and sorting your reports. You can build reports in Power BI, and this offers interactivity, such as creating the ability to navigate across your reports and selection opportunities to sort and design them. This means your report becomes inclusive for everyone who interacts with it. Let's talk about how we can filter and slice our data at a visual, page, and report level. There are a few different ways you can filter your data through transformations, measures, visualizations, and also inside of the report. One icon is called the slicer. A slicer is just a type of visual that you can use to add to your report so that users can segment the data by a specific value. The slicer narrows the portion of the semantic model that is shown in other visualizations too. And it's quite useful to allow the ability to filter within the report itself by filtering columns that are needed and also removing the ones that are not needed, even inside of a data table. It enables a more focused view on a report, and this can also be customized using tiles. While slicers are very useful, if you want to filter your data in a basic way, you don't actually need to add slicers to your report. Did you know that Power BI Desktop has a filter pane that can handle the basic slicer operations? Well, depending on your requirements, you might save some time and effort by avoiding creating these slices and simply just use the filter pane instead. And this has the added benefit of reducing the total number of visuals on a report, which consequently improves performances. So as you can see in front of you, there are different level filters that can be applied at a visual, a page, or all pages in your report. We can then filter based on a basic query, an advanced query. We could take the top number of values, some form of relative date or time, depending on the data type you're faced with. Let me show you this inside of Power BI. So I have a report here. And let me just show you first the slicer tool. We have this slicer tool that exists here because what it's doing is it's going to be filtering out data based on Europe. Now, if I didn't have any of the slicer values on, it would take the entire world and it would then update where all of my data is inside of. But by using the slicer tool, I can then get a little bit more of a granular view. Let me just jump back into Europe. And what you will find is that when I use the slicer tool, it cuts across all of the elements inside of a graph, right? I can click my columns, and if I click on that column, it will filter it out to that specific area, and I can use that to understand and explore how it works. Now, when we talk about filters in terms of the actual page review, there's actually a little property panel that you can play around with that appears, again, depending on how your user interface looks. But in general, what you need to find is where it tells you how you can filter. So if I just take this off entirely, I can do the exact same thing using the region. Let's add that here. So sales region. I believe, is it this one? Nope, let's go find it in our little data set. So country and region, let's go grab the sales region and drag and drop it into our environment. And if I scroll down, you'll see that it appears here. So if I just click Europe, you will find the report filters by Europe again, right? So this is what this filter tool allows me to play around with. And some things that are quite useful here is that I can customize it so that I can lock it to say, hey, I don't want users actually changing this value when they play around with the report. So it will restrict them to what they can and can't do. And it applies to the filter level. You can also hide the visibility of these types of tools. For instance, I can just say, hey, I don't want this to be shown, or I do want this to be shown, based on how you want your users to interact with the data. And when you're done with what you need to do, you just minimize it. There's also the tool that you have available where you can be in complete control as to how you intend to sync up your data between your pages as well. So by clicking the sync slicers option here, it will allow you to say, hey, if this one is on in one thing, which parts of my report will interact with the other? So there you have it, an example that explores the filters that you can apply at a report level. We discussed the importance of filtering. It can be very useful to give your users that power to explore the data in a way they want to, and also control how they want to interact within your report. You can also play around with the filter settings to ensure that certain tables don't get impacted. Let's talk about how we can paginate our reports so that it can be useful beyond an analytical perspective. Paginated reports are ideal for creating sales invoices, receipts, purchase orders, and tabular data. Let's look into how we can work with our reports and add parameters, tables, charts inside of our paginated report. And additionally, you can use paginated reports when you expect to print that report on paper, or for when you need an e-receipt, purchase order, or an invoice. Paginated reports render the tabular data exceedingly well. You can have customized sort orders, clickable headers, and URLs, which means that you can have a simple integration with custom applications. Because they can display our tabular data really well, we can put all of our data in a single report element, such as a table. So if you wanted to, you could have 50,000 records. You could actually print this across 500 pages. And if you wanted to do that, fine. And if you wanted to print every third record to have a light pink background, you can do that as well. So depending on the license type, your paginated reports will have different features available. So for instance, a pro user can publish to a different workspace. So how does it work? Well, you need to open up the Report Builder app, which is a separate download. You will need to make sure that you download it. And then once downloaded, all you need to do is open it up and start working on your reports and making your changes, running when you are ready to work with it. When you create and run your elements, you then publish a report into the Power BI web service and allow the rest to do its magic. Again, depending on your subscription license will depend where. Working with paginated reports should also be done when you have the right permissions. Let's conclude. A paginated report transforms your report into a readable printout and requires a different service to create them. I recommend jumping into a tutorial to really get the feeling for how this works. Until then, learn anytime, anywhere. I'll see you soon. The narrative of your report is key to creating impact. Hi, my name is Victoria, and I'm happy that you could join me today. From a visual standpoint, your primary goal will be thinking of a user and how they will interact with a report, not from the perspective of you working and interacting with it. You should think about the type, the number, the positioning and placement, the size, and how the user will interact with it all. You might want to use a combination of visuals when it comes to using the type, such as cards, charts, tables, and slices. It is important to use the right number of visuals on a page and then size and position those specific visuals in the best way. Then we have the number of visuals. Consider using a number of visuals that contains slices that you want to use inside of that report. It's best to limit the number of visuals to a smaller number on a specific page, because the more visuals might have the opposite effect of what you're actually trying to achieve. You may get distracted a lot. So rather than using multiple visuals, you can provide information in other ways, such as drill through, working with the report page tooltips. Let's talk about the position of your visuals. The placement depends on where you move those visuals within a specific location on your page inside of your report. You can make them bigger or smaller for a more effective display. It's best practice to place the most important visual in the top left corner of your report, as users are more likely to read from left to right and top to bottom, but cultural differences may vary. Then let's talk a bit about the size of the visuals. Power BI determines the size of the visuals by default, but you can resize visuals to present the information in the most optimal way. When it comes to working with the interaction, the visuals that you work with may or may not interact with one another, depending on what you customize. You can select an element in one visual that will then update other visuals in relation to your selection. And as you design a report, it's important to understand that visual interaction might affect the overall user experience of the report. And speaking of this interaction, we also have our hierarchies and drill-throughs. So you should consider how hierarchies can affect how the data is displayed within these visuals and how a user may navigate through it. You can also determine the hierarchical path of the visuals so long as you have the full control over what level of detail you want to be accessed and what you want your users to access. Next, let's talk about your business objectives too. Nikolai Schuler, another Power BI expert, also broke down the storytelling into 3 main points. You should be thinking about the requirements of your Power BI users and stakeholders and how they intend to use the report. You should think about what KPIs they want your report to be addressing, and as well as how the information is going to be presented to them. So when we talk about the requirements of a user, we need to be asking the right questions. We need to understand who our target audience is. Is it a management? Is it a senior leadership team? Or is it a person on the ground? How will you build your report? So here's some questions that you can be addressing. Who is using this report? Which reports are currently in use? What is the goal of this report? How do you use these goals to meet your specific purpose? And how can you identify the most suitable KPIs? Do not ask your user or your client, what do you want to see? Instead, understand what metrics they have available and what they are already using. Is there elements in your report that are not in place, that are missing, or that your users are struggling to work with? And can you ask them to show them, can you ask your clients or your stakeholders to show them what they are currently using and think about ways of making it better? And lastly, when we think about our effective visuals, we should be asking ourselves, does the visual fit the data that we actually are presenting? And is it actually telling us the best way to explain the message? And think about what actually is your message. So I would like to jump into our community channels and look at our data stories, because I think they show a great example of how this all works. So I'm going to jump into our community channels and look at our data stories. And one of these channels inside of these community environments are these galleries, which explore, for instance, COVID-19 data. Now, during that specific time, a lot of the public were using this information posted by our government and research facilities about the rates of infection, about the types of fatalities, the recovery rates, the vaccination periods. And as a result, we started using dashboards as a way to represent this data. Let's just take a look at one of them, which explored this in greater detail. So what I think is quite cool about this is that you can then pick and choose and gain a lot of inspiration from these community channels, interact with how they wanted to perceive this data, and learn what makes an effective visual to them. In this report, we discuss the importance of storytelling using data. It comes from a visual approach as well as being able to meet your users' needs. Take some time to dive into the community channel and pick the reports that grab your attention. What makes them great? Why did you pick that specific one? And can you see ones which you dislike? Why? Learn anytime, anywhere. I'll see you soon. Let's talk about some additional features that can further enhance your Power BI environment. We're going to look at the ability to analyze our data, group our data, identify outliers, and a few others. The Analyze feature provides you with additional analysis that is generated by Power BI for a selected data point. You might want to use this feature to see if Power BI has done something that you haven't looked at before, or if you want Power BI to give you a different insight to your data. This feature is particularly useful for analyzing why your data distribution looks the way it does, or look for increases or decreases in the data. So instead of exploring the data manually, you can use this feature called Analyze to get a fast, automated, insightful analysis on your data. Let me show you. So inside of my report, I have a bunch of data points. And what I can do is I just need to right-click to see if I have the ability to do it. So as you can see, in some of these graphs, I have the ability to explore certain features that pop up. For instance, I have the ability to look at where this distribution is different. And if I click that, something pops up. And AI is going to be working in the background that will come up with ranking metrics to tell me why there is a change in the distribution across my data set. So for instance, we can see this home data consists of nearly a quarter of the records, whereas the remaining values are somewhere between this 8 to 11% mark. So we can definitely say that the 090 home category is going to be impacted quite a lot if the data changes or significantly differs. That's not the only thing you can do inside of this Analyze tool. So let me just jump onto another example, and I'm going to just right-click this specific table, because what I can do inside of this Analyze tool is explain increases and decreases as well. So what this means is it tells me that, hey, there was actually an increase in this specific year between 12 and 13. And what this means is it tells me that, all right, based on this specific location, there's one specific territory that accounted for a lot of it and another territory that accounted for the decline in the sales. So this Analyze tool is quite useful to work with just to get a quick overview to understand why. Why did this happen? What do I want to understand with this specific data without actually having to create DAX queries? When you create visuals, Power BI Desktop aggregates your data into groups. And this is based on the values it finds in the underlying data. You can define how those default groups are presented, group data points to help view, analyze, and explore the data more clearly. You can also create new groups by grouping 2 or more data points in a visual or putting values into equal size groups, which is referred to as binning. And this better enables you to visualize data in ways that are more meaningful. Grouping is used for categories of data. Binning is similar to grouping, but it's actually used for grouping continuous fields, such as numbers and dates. You can use the grouping and binning features to ensure that the visuals in your reports display your data exactly how you want them to, so that you can clearly view, analyze, and explore the data, as well as the trends within your visuals. You'll also be able to identify clusters, patterns, behaviors, data averages, and more. The result of this analysis will provide your end users with more specific insights of their data, which can drive business decisions. Let's jump into Power BI, shall we?
In this report, I have a graphic that contains a bar chart of a series of dates. And let's say I wanted to group the data based on quarters. Like, I don't want to create a whole new table for that, but maybe just as a visual aid to those that are looking at this report. So what I could do is I can click the columns, and I'm pressing the control key here to click multiple columns, and I'm right clicking this, and there's this little group data option that appears. And if I click that, what you will find is it will group just the columns that I clicked, and then the rest will be labeled something else. So if I click on these next 3 quarters, so this is quarter 2 now, I right click, I group, I can do the same kind of visualization effect. I continue onwards with my categories. And yes, for this represents my quarter 3. And for the last one, I could just leave it blank, right? But I mean, we may as well just finish things off as neatly as they possibly can. Just note that when you group your data, it will depend on the visual formatting tool that you use. And so what I have now is I have 4 groups of data that are shown, right? If I hover over here, that's quarter 3 and quarter 4. Now, just to double check this, inside of my column tools, although your Power BI desktop environment may vary, we have the option for these data groups. And if I edit these data groups, I can rename this, right? This is actually quarters. And you will see that I have my 4 groups highlighted. I also have this other category, so let me just click that. And if I wanted to change, for instance, how I go about my grouping, I can simply ungroup and redo them as well. And when I click OK, what you will see is, if you pay attention to the data, is that it creates a little metric here. It's a measure that I can't really use outside of the column conventions of the month. But yeah, it's a good enough metric for now. So I know also on my graph, if I look over here in the bottom corner, or if I zoom in just a little bit, you can also see that me renaming this to quarters also affects the legend in my graph, and I can incorporate it here. So this was the before, and this is the afterwards.
So that was an example of how you could group your data. Now, the next one we can look at is identifying our outliers within our data. And an outlier is a type of anomaly that exists within your data, something that you didn't expect or that surprised you based on, for instance, historical averages or results. You will want to identify outliers to isolate data points that are significantly differ from other data points, because that can really impact how the result will work. So this means that you should take action to investigate the reasons for the various differences. Now, in terms of a scatter plot, it's generally just one of these icons that exists inside of your map, inside of your Power BI report. So what I can do inside of my Power BI report is I have a scatter plot prepared already. And what we can do is, if I take this value, we can start looking at how the data looks across it, right? So I can then think about, right, does this specific value make sense? And talk to the various stakeholders that I have available. One cool thing about scatter plots in general as well is I can also use this play axis down here, and you can create a little bit of a time lapse as to how the data behaved. And in this situation, it's a time lapse of the data across the various months in terms of behavior. And you can see right now that genuinely the data is quite similar to one another. So outliers can be used to help you identify unexpected deviations within your data. Clustering allows you to identify a segment. And this can be very similar to each other, but very dissimilar to the rest of the data. And the process of clustering is different to that of grouping, which we just discussed. Clustering allows you to quickly find groups of similar data within a subset of your data. It analyzes your semantic models to identify similarities and dissimilarities within the attribute values itself. And then it separates this data into specific subsets of the data itself. And these subsets are referred to as clusters. And I really recommend you check the documentation out to see how it works in detail. We also have key performance indicators, which are excellent in helping you track progress towards a specific goal over time. To use a KPI, you're going to need 3 different types of information. And let me just show you this in Power BI. So in my KPI index, I'm just going to select the specific card. And when I do so, you will see that it's going to ask you for various things: value, trend, and target. The value is a unit of measurement that you want to track. For instance, the total sales, the number of employee hires, the number of loans serviced, or even just the number of students enrolled. Then you have the trend axis, which is a time series, for instance, coming from your daily, monthly, quarterly, yearly time values. And lastly, you have your target, which is represented as your goal for this measurement so that you can compare your progress with the goal that you need to. So KPIs work best in a series, for instance, showing the daily, monthly, and yearly goals within the section of your Power BI report. You can also use what-if parameters, and these are very useful when it comes to running scenarios and scenario type analyses on your data. What-if parameters are powerful additions to your Power BI data models and reports because they enable you to look at the historical data to analyze potential outcomes if a different scenario occurred. Additionally, what-if parameters can help you look towards, predict, forecast what potentially could happen in the future. And what-if parameters can be used in multiple situations, such as to determine the effect of an increased sales to a deeper discounts, or let you simulate how sales consultants see their competitions to see if they're going to meet any sales goals or percentages. We talked about some enhancements that you can use within your features to support you in meeting your objectives and business needs. We used the advanced features to help us identify additional trends and patterns through our visualization tools. What I would say is you should try it for yourself. Pick any one of the methodologies discussed and experiment. Let's talk about how Microsoft has incorporated AI into Power BI tools. We're going to start off with the visual and then move into some other features where it exists. So let's jump into a Power BI report. And in particular, we're going to talk about the visuals that utilize AI. Now, inside of Power BI, if you've worked with it already, you may have come across when you're exploring the different kinds of icons that there are AI visuals. And we're going to jump into them. Specifically, I'm going to start off with this Q&A icon available. And what the Q&A icon does is it allows you to have a little bit of an interactive discussion based on the data inside of your report. And what this means is I can ask questions about my report, for instance, finding out the data. And we're just going to use the standard one to get started. So if I just click this, what is the total sales by category, Power BI will go, hey, let me just show you the specific results. And I can zoom in or zoom out depending on what I'm interested in, and it will just tell me a little bit about it. Now, just note with the Q&A that if you are creating a measure table, as you can see on the right-hand side here, where there is no actual physical data storage, sometimes the Q&A won't be able to work as effectively. Let's look at another different visual. So we have discussed the Q&A. Let's now jump into the key influences. And what the key influences does is it tells you, based on a specific value that you declare, you can then determine what is the cause behind it. So for instance, what is the cause behind the total sales? What caused the total sales to decrease or increase? And what you do is you just select the different kinds of variables that you want inside of your environment, and it will do the rest. So for instance, the total sales increased when the fashion district was the chain, the category was the fashion district. And you can find specific information. All you need to do is just drag and drop the information into that. We also have our decomposition graphs, or decomposition trees, I should be more specific. So let me just unhide this and we'll find it inside of our report. So the decomposition tree is, so the decomposition tree basically says you're going to start off with a singular value. Let me just get rid of these and we can explore them in greater detail. So you start off with a specific value and you ask yourself, all right, what are the major causes behind this regular sales? And you can say, hey, I want to break it up into the highest or the lowest value, or I want to break it up by a specific time, as I used as an example, the monthly value. So I can identify and say, all right, so the majority of the contribution of this data came from August. And the second highest was March. And what I can do further is break this down into another step. So I can be like, okay, so August was the highest contribution to the sales for the specific dollars. Now, what caused that? What was it? Which chain caused that specific thing? And it will tell you, actually, it was the Fashions Direct. So you can see the different kinds of the key influences and the decomposition tree telling you the same thing, but just slightly differently. And you can just say, all right, so in August, the Fashion Direct was the highest contributor. Lastly, we have our tool, the narrative option, which is the summarize tool. And what it does is it basically just gives you a summary of the data that you have. If I right-click some of the data that I have available to me, it will then just present a text about what I can see inside of the specific report. So I can be like, okay, so the total sales decreased when the specific values happened. And this was taken from the key influences graph as well. So just note that if you have the option, if you right click a graph, let me just click one of them in a different part of the report. If you right click a graph and there's this option for the summarize, this summarize will then provide you a little bit of a summary. And so you don't need to write it and you can make the analysis, take the analysis that it uses from there. So that's not the only area where you can actually work with artificial intelligence. You can actually jump into other elements of the Power BI desktop. So for instance, inside of Power Query, we have machine learning tools and the cognitive search, which is very useful for decoding our images into text, finding semantic information, as well as taking away to key index searches as well. And this means that not only are we limited to our data of being either categorical or numerical, but we can then start bringing in our documents. We can start bringing in our images to start building a proper report based on what we need for our business needs. So we are not limited to just working with numerical and categorical data. Lastly, we also have the ability to have Copilot integrated into Power BI. And inside of Copilot, we can work with measures. So Copilot is quite a useful tool if, for instance, you're very new to working with Power BI's programming, DAX. So inside of my environment, what I can do is I can create let me jump into my visual report. I can jump into and create a quick measure. And when I create this quick measure, of course, I can create something by talking, but I can also just go right into Power BI and be like, hey, can you give me the total number per category? And what it will do is it will generate a response. It will give you this actual answer in case that was your quick answer value. Oh, I didn't fully understand that. So let's ask, what is the total sales? Not total number, it's probably the total sales. Got confused with that per category. So if I run that, then it should show me a specific value. So it's saying the total number per each category represents this, and then you have your DAX query, and all you need to do is just add it into your report and utilize it as needed. We discussed how Power BI uses the power of artificial intelligence in its visuals, transformation, DAX queries, and beyond. Learn anytime, anywhere. I'll see you soon. Hi, I'm Victoria, and I'm grateful that you could join me today. At this stage in our data journey, it's time to think about sharing and distributing our reports. And to do that, we're going to need to start thinking about enterprise scale and stronger engines that can support a lot more users interacting with them. As we start to jump into these more intensive loads, we enter the cloud. Enter Power BI Service. This is the final resting place of your reports, where you can now watch the effort you have invested over this time period into that report and start to drive impact. This will support in decision-making and finally unlock all that potential that you knew your data could bring. Power BI Service allows us to publish our reports to the cloud and share them with others within our organization and externally. This allows us for easy collaboration and access to the data no matter where our users are located. Additionally, the Power BI Service offers powerful features such as data refresh, row-level security, and usage metrics to help us manage and monitor our reports at an enterprise scale. In this section, we introduce the Power BI Service and all of the lovely features that come with it. So you're done preparing your report. How do you share it out? When it comes to enterprise scale and collaborating with our colleagues, we are going to connect our report and semantic models to a shared environment. This shared environment is Power BI Service. Let's explain how to go about creating our components within our Power BI Service, such as our workspace, and detail some things that you should know about there. Our workspaces are the shared environment where we can provide security over who accesses our semantic models, reports, dashboards, and apps. But let me just show you how you can set one up. So I've navigated to the Power BI workspace, and inside of this environment will depend on how your company utilizes it and your subscription tier. So when it comes to working with workspaces, every single user will have their own. And this is a very good place to do your sandboxing, to experiment with things, to just try things out. So as a new user, and your company has a Pro Plus license fee, you should know that you can jump into it. The licenses will dictate what kinds of workspaces that can be hosted, and as a result will determine the kinds of features available to you. So what we're going to do is I'm just going to set up a completely brand new workspace. And bear in mind, I do have administrator permissions available to me. So as an administrator, when I create a workspace, all it's going to ask me is to come up with a name. So for instance, let's give this one a name for our Power BI market report. Right, so this is going to be what everyone that I incorporate into here. So this is what I'm going to be telling everyone to incorporate into the environment if they need to share any reports or semantic models or make changes. This is the name that they're going to be finding. So if I do that, I can assign a domain should I have a Fabric license. And if I scroll down to this advanced section, you can see who already gets associated to it. So I can give it a Pro, I can give it a premium per user subscription. Let's go for that one. And I can also determine the kinds of users that have access to this. It could be a username or it could be a security group. So for instance, I could have my Synapse members on my team jump into a specific group list that I have available. So when I do that, I can apply this specific workspace, and what it creates is this new environment. This is a shared environment that others can collaborate on, and I can upload my reports from a OneDrive, from a SharePoint, or from another environment. I can also create a variety of things depending on the accounts that I have available. So what do I want to do inside of here? Well, for instance, we have created a report, right? So we would want to ideally store our data inside of there. So what we're going to do is I'm going to jump into my value here. So I have this report. The way I can bring this into my Power BI workspace is, if you see here, this little publish button. And this allows me to share it out. And when I select this, let me just save my settings. I can then choose the workspace that I want to push it to. So this Power BI market report. So now what it's going to be doing is publishing this into the report, and all it is just a waiting game as to how you can work with it. And the reason this is quite interesting is because depending on how you've built your semantic model will depend on what kinds of things you have to do inside of it. So let me just jump back into my report, and if I refresh my, it just loaded automatically anyway, but if I refresh my page or just wait a little bit, it will load this report, which I can click, and it will show me what we've just built. So this is now inside of the cloud, and I can work with it and I can use it to play around with, for instance, Copilot to help me with a little bit more in, for instance, designing this report or understanding this report and working with my collaborators. I can also set alerts, I can retrieve insights, I can work with this environment as and when I see fit. And that's just an example of this specific environment. So let me just jump back into my workspaces and show you a couple of other things. So we have this Power BI market report, and if I show you the semantic models, you will find that there are other settings that I can play around with. So for instance, I can play around with the security side of things. So if I jump into the settings of this specific environment, I can then set up, for instance, my gateway and cloud connections, or if I need to refresh my data. Just note, there's quite a lot of things that you can jump into, and depending on the mode of data, the storage mode that you have available, it will compress the data and try and make it as efficient and effective as possible. And with these license subscriptions that start to reach into the premium, such as the Fabric subscription, the premium per capacity, the premium per user, what you will find is that there you can start enabling larger models and semantic models. Now, one thing that you're going to want to be doing is inviting your colleagues into your workspace environment. And you're going to be assigning different kinds of users to it. And these are referred to as your workspace roles. And there are 4 different types of users that we have available. We have the admin, which has complete access to the workspace. They have control over managing the access. They're able to delete the workspace. They can contact support. They're in charge of that specific little category. Then we have the contributor role. And inside of this contributor role, they are able to edit and publish the content in the workspace, such as the data sets, the semantic models, the reports, the dashboards, and the apps. Then you have the member role. And inside of the member role, they're not allowed to add users or delete the reports. And lastly, we have the viewer role, where the user is only allowed to read only on the data set. This means that they can't publish reports to Power BI. They can't create or modify what's inside of those reports or dashboards. The only thing they can do is just look at the data and look at the finalized report. So as data analysts, you are going to be in charge of either having a member role, a contributor role, or an administrative role. I would recommend checking out the documentation just in a little bit more detail to know what kinds of capabilities each role can work with. And it's also quite useful if you plan to take the exam to know this as well in the back of your pocket. So let me just jump into my workspace again. Just going to show you how you can go about setting up a role. So if I jump into workspace and I use my Power BI market report, what you will find is there's usually these ellipses everywhere. And inside of these ellipses, you can then set up specific values. So manage access is about setting up those roles. As you can see, my account has an administrator, but I can, for instance, add a specific user. I can add my specific user based on a name, an email, or group. That's quite a useful one to know. But you can give them the role that they want and a specific kind of permission. Okay, so one thing I would be advising you to do is always choose a security group over a user. And the reason I suggest this is if a user leaves your organization, then you're going to have to remove them. For instance, if I add this, I'm going to have to remove this viewer, this specific user from my report. If I click this workspace settings and manage the access side of things, I'm going to have to jump into here manually or use the Power BI API to remove them from that environment, which makes it a little bit more time consuming and resource intensive. Whereas if you assign them to the group, all you need to do is just remove them from that group, and the group can always just remain as is. So that's an example of how you can work within your Power BI and assigning your users. We discussed that once you're ready to share your data out, you publish your report inside of the Power BI workspace. And this workspace is a shared environment, so you will be able to distribute your content to your users and also decide who has access to it. Let's dive in and explore the various workspace items you have inside of your workspaces. Just so you're aware, I am an administrator in my demo, so I have quite a lot more options available to me. So let's jump in and take a look at the workspace. For this specific example, I'm just setting up my workspace because it allows me to show you quite a few more options. Now, when it comes to working with your workspace, you have different things. You can create a new report, a paginated report, which is the printed out version of your reports. You have your scorecards, which are like trackers to make sure that you are on track. It's like a KPI kind of indicator that's built inside of your service. We have our dashboards, which are the singular view across different reports and visuals. So it's more like an overview and summary. We also have our semantic models, any references to streaming data sets and data flows. As you can see, there's quite a few options you have available in here. It will depend on the license subscription you have, which is why I kind of wanted to show you it. Now, let's just jump into a few common items that you're going to be facing. So we're going to just jump into this report and see what you can actually play around with. So I'm just going to click this specific sample data set surrounding artificial intelligence. And what I can do inside of here is I can share it out to my colleagues. That's the first thing you need to understand, is that this service is a place where you can share things. And inside of it, there are buttons that allow you to say, I need to extract specific information regarding the data. Oh, in this situation, not this one doesn't have very many insights, but you can use it based on your specific semantic model. You can utilize Copilot to help you understand where possible. But again, Copilot needs to be utilized based on your subscription, needs to be enabled or disabled based on your administrative settings. So your organization will determine whether or not you have these capabilities. You also have the ability to view where and how it's being utilized, how people are utilizing these reports, and also to pin these things to dashboards. If you want to edit your reports inside of Power BI, it is completely possible, but just note you are only restricted to the visualization view. So you can't play around with the semantic model. If you wanted to do that, you'd have to jump back into your desktop and make those tweaks there. But just note that you can play around with it from that perspective. And let's talk about those semantic models, because the semantic models is the accumulation of the data source assets that we have, the transformations that we've built, and the total relationships and queries that we've made. And this semantic model is the culmination of everything. And as you can see, there's quite a few things that you can work with when it comes to this specific data set. So let's just jump into the settings. Now, inside of the settings, you have quite a lot of controls that you can play around with. So when we talk about these gateway and cloud connections, these are the access and permissions that your company works with. So for instance, are you working it in a development environment? Are you testing things out? Or are you connected to an organizational side of things? You also have the ability to set up sensitivity labels, check that you have the right credentials if needed. So for instance, coming in from SQL servers, you have mentioned sensitivity levels. We have the ability to refresh our data. So for instance, if you're working with the import storage modes, how setting this up so that it can configure. Inside of Power BI, those refresh modes will depend on your license subscription. So currently that is for a pro user, that is 8 times per day. And for the Premium Plus users, that can be up to 48 times per day. But I would recommend you always check the documentation for the latest up-to-date information. We have various elements to this semantic model that allows you to start working with your environments. And this also allows you to play around with the dashboard settings. You can play around with how your data flows look. By the way, a data flow is the Power BI dataset equivalent of bringing in data so that it's reusable and repeatable. Now, because we are sharing and we are in a collaborative environment, we need to also think about security. So in order to do these kinds of security elements, there is the option to work with row-level security, which has been built into your Power BI desktop. So when you assign a user to your specific workspace asset and you're going, hey, I want this user to be a part of it, then what that means is that the row-level securities will immediately apply based on how you set those up. So the Power BI allows you to experiment with different kinds of environments. So one other thing which might be very useful is if I go over here and hover my mouse over this lineage view, the lineage will allow you to see how the data is being utilized, where it's coming from, where you're drawing it in. So for instance, let's find that artificial intelligence model. I'm sure it's here. There we go. So it's taking data from a specific gateway, is retrieving the data into a semantic model, and then it's using in a report. And this is very useful if you find that your report becomes a template and people build off of your report. So you can see how the report is being utilized. Maybe it's being worked with in further reports, or maybe it's being incorporated into a dashboard environment. So this is quite a useful tool to work with. As Power BI is this collaborative environment, you can even leave comments on reports, and these comments can be incorporated into your paginated environments, your dashboards, as well as any visuals. So anyone with the right permissions can see those comments and even contribute towards them. So when you add a comment to a specific visual, rather than the report, the context of the comment becomes more clear. So this is recommended practice and can act a little bit like a personal bookmark. In this video, we explored how you can work with your assets, deciding how to customize it and set it up within your reports within the Power BI service. So it's ready for your colleagues to interact with. So inside of our Power BI service, we touched on the report, the semantic model, and now it's your turn. I'd like you to take it one step further. You can choose any component you saw inside of your Power BI service, something that made you go, what's that? And dive in further. Dashboards are high-level overviews and summaries of the reports and semantic models within your workspace. Let's take a tour through Power BI service and take a closer look at dashboards in greater detail. A Power BI dashboard is a single page, often called a canvas, and that tells a story through visualizations. Because it's limited to one page, well-built dashboards capture the main, most important highlights of the story that you're trying to tell. Readers can view the related reports for these details. So I'm inside of my Power BI service environment, and I'm currently working on this report that's been published. Now, I don't want to share the entire report onto a dashboard, although if I wanted to, all I'd have to do is just pin this to a dashboard and the entire report gets included. But I think what we need to do is start drilling down a little bit on our data. So I'm just going to navigate by this major opportunity, right? The opportunity is what is probably going to be the most important things to our senior leadership team when it comes to working with it. So inside of my product, my environment, I've reduced it down to the east environment. So as you can see, I can interact with this data. And let's just go for, we can choose a specific location to explore. So I'm going to choose this one just to understand where it's coming from. So once I've played around with this environment, I can then decide to say, right, this is a good visual, or this is a good amount that I can see. So I'm going to take this revenue by state and go, it seems like a great environment to explore in greater detail. So when I jump into this drill through option, it tells me a little bit about this specific report, and I can jump up and I can jump down depending on the environment, depending on what is working for me. And what you will find when it comes to working in the service is that you will always get these three little, you'll get these three little ellipses that you have available where you can start thinking about, well, do I need to actually explore this in greater detail, or do I need to retrieve it at a later point? So when it comes to working with a dashboard, you will find that there is this little icon here which says, hey, let's pin this to my report. And when I pin this value to my report, I can actually decide if I want to pin it to an existing dashboard or a new dashboard. So let's give this a name. We'll call this the revenue opportunity dashboard. And I can either use the destination theme or keep the current theme. But because this is a brand new one, I will have to set this up. So it's pinned this to this dashboard, and we're going to jump into the dashboard first, and later we'll start exploring this mobile view. So as you can see, this is inside of my dashboard is this canvas. And in this canvas, it means that I can start going based on that specific workspace that I'm inside of. I can append different kinds of reports inside of it. So this specific report came from my workspace. So let me just jump into another example of a report. So we did this one. Let's bring in our opportunity analysis sample. I'm going to just click this. I'm going to open the report, and we're going to append it to the same environment. So we've got our East, West, Central. I think this one would probably be very useful for our senior leadership team. So I'm going to click the visual. I'm going to append it to my existing dashboard and pin it. And once you see that, you can then notice that this report will start stacking up, and inside of this canvas, I have a different variety of views. So what can I actually do beyond the pinning of the reports? Well, I can edit the data. I can create these things called tiles, and tiles can be incorporating images. It could be incorporating text boxes, web content. I could be incorporating videos, just to make sure that the narrative that I want to tell in that summary is there. And I can also connect to my real-time streaming data. I can also play around with the dashboard theme. So for instance, if your company works with a specific theme, or you want to work with one, you can upload a theme, or you can use the default value. So for instance, let's go for a colorblind friendly report for accessibility reasons. And when you are ready to start experimenting with the actual report, so let's just say these two visuals are the only ones we want to go about, well, we can start playing around with these mobile visuals and just detail them. So not only can you create the mobile layout inside of your report view using your Power BI desktop, you can also play around with your dashboards working within this mobile view environment. Let me just do that. And I'm going to jump back into the web layout. You'll notice at the top here, there is the ability to enter Q&A. Now, Q&A will be either disabled or enabled in your organization, but what you will find is that you have the ability to tell a story. And you want to tell a story in a user-friendly approach. And so inside of our canvas, we can actually use natural language to derive the fastest approach to getting a story. So for instance, I can explore the opportunity count by state. So if I click this, it will then create a report, and I can jump into it. Now, this is inside of my dashboard, but this is just me having a little bit of fun in the environment itself. And if I think the data I have is worthy of being shown, all I have to do is pin it, exactly as I have shown before. So inside of your dashboard, you can use a Q&A feature that contains a question box where a user enters your questions. It provides suggestion tiles based on the information. And because it's a dashboard, you get the ability to pin it. A second feature will be the Quick Insights, which runs machine learning models over your entire semantic models to produce insights very quickly. And it's only available inside of the Power BI web service. Just note that Direct Query won't work with the Quick Insights tool. We explored how you can work with your dashboard, which can host a variety of report visuals on a canvas. Your job now is to experiment and customize any dashboards that you've built so far. Experiment with the tiles and see what you can create. I look forward to hearing what you come up with. Apps are the tools that you use to distribute your content to a larger audience. Let's explore how to use a workspace app for content distribution. An app is a Power BI content type that combines related dashboards and reports all in one place. An app can have one or more dashboards and one or more reports, and they're all bundled together. Apps are created by Power BI designers who distribute and share the apps with consumers, like you, your colleagues. Your apps are organized in the app content list. Content can be in the form of reports, dashboards, semantic models, data flows, and more. An app is a published, read-only window into your data for mass distribution and viewing. And when you are ready to share apps with your users, you can publish it. This process requires a Power BI Pro license and beyond. And when you're ready to publish your app with its collection of the reports, the dashboards, the semantic models, you will navigate back to your workspace and create an app in the top navigation ribbon. The first step is the Setup tab, and give that a name, add a description, add an app, maybe a logo, think about your theme color for your company if needed. And you can also change the order in which these items are displayed. The next step is the Content tab, and you select the content to include. You can add sections, links, and reorder the content as needed. The last step is the Audience tab. You grant access either to all the users in your organizations, or you can select specific users or groups to have that access. And now you can also create multiple audiences if you have a report that may be viewed by a diverse group of people. But just make sure they're the ones that need the access to the certain portions of the content. Bear in mind that this doesn't replace row-level security, but it's another tool. Upon making edits where necessary, you can publish the app, and voila, you've published an app, and you will get the following screen as you see in front of you. This will present a link that you can then share with your users. After publishing your app, you realize that you would like to make updates within your workspace. So, how do you do this? You're going to navigate back to your workspace, and you're going to make any updates required in the reports or dashboards. And this workspace will act as a staging area, so you can make any changes needed. But they won't be added to the app until you select this Update App inside of the ribbon corner. Just note that your semantic models and data flow updates are updated immediately. And when you select this, you can make any changes to the setup, the navigations, the permission tabs, as and when it's needed. This video explored the purpose of an app. An app is a Power BI content type that combines related dashboards and reports all in one place. And this can be shared out to consumers, users, your colleagues. You can also use the names, the descriptions, the logos, the content itself, and decide on the audience of that app. Any changes that you make inside of the workspace will also need to be updated. You should dive into the documentation to see how you can further optimize it. Let's touch on these other need-to-knows ranging inside of the Power BI service. These are things like the governance, access, and gateways. Sensitivity labels provide a simple way for your users to classify critical content inside of Power BI without compromising the productivity or the ability to collaborate. Sensitivity labels can be applied on semantic models, reports, dashboards, and other workspace assets. The way you enable your sensitivity labels is actually inside of your Power BI desktop environment. All you need to do is select what you want to do and apply it depending on your organization's restrictions and policies. And what this means is that if someone were to open up this report outside of it, it will automatically apply a sensitivity label based on the exported data. When data is exported from a Power BI to an Excel, a PowerPoint, PDF, and other files, Power BI will automatically apply these sensitivity labels on that exported file, and this will protect it according to the labels file encryption settings. This way, your sensitive data remains protected no matter where it is and who gets it. This inheritance also gets applied upon new content, and it gets embedded inside of your apps or live connections. When you enforce governance policies, even inside of your Power BI content, it will export the formats to help it ensure that it's protected even when it leaves the Power BI environment. Once you've secured your assets, the next important thing you should be aware of is the role of endorsing your semantic models, reports, dashboards. If there are thousands of reports, some experimental, some of them improved versions, how can you flag up the one report to rule them all, especially to the appropriate channels? Okay, I'll make an exception to reports. But this is where the endorsement plays a role. Endorsement provides a measure to manage semantic models. Again, to ensure that your organization has consistent data for making decisions as well as a healthy data culture, it's really important to create and share these semantic models and then endorse them as the one source of truth. The benefit here is that a report creator can then reuse that endorsed semantic models to then build their own accurate and standardized report. You can endorse your semantic models in the service. You can use a promotion and certification. Promotion is when you promote your semantic models and they're ready for broader usage. Certification is when you are requesting a certification for a promoted semantic model, and it becomes this highly selective process where someone truly reliable and authoritative will tell you that the semantic model can be used across the entire organization. As a user, you can promote. As an administrator, you can certify. Check the documentation to learn more. We then have our gateways, which act like a bridge, allowing our organizations to retain other databases and other data sources on their own premise networks. Well, it's still being able to access the data within our cloud-like services, such as Power BI and Azure Analyst services. A gateway facilitates a quick and secure communication. It flows from a user in the cloud to your on-premise data source and then back again. There are different types of gateways, and we'll explore the organization and personal mode here. The organization mode allows multiple users to connect to multiple on-premise data sources, and it's quite useful for when you have complex scenarios. The personal mode, on the other hand, allows one user to connect to the data sources and can only be used within Power BI. It can't be shared with other users, so it's only suitable for when you're in a situation where you're the one in the organization creating reports. It's important to note that if you set up a data gateway incorrectly, you may find it difficult to connect to the data. Always add this to your checklist when troubleshooting import problems. We discussed how we can secure, promote, certify our workspace assets using our sensitivity labels as well as endorsements. We also touched on the role of gateways for connecting to on-premise data sources. If you have a report that you're working on, what kind of sensitivity label are you using? What you can do in the Power BI service depends on three things: the type of license and subscription you're using, where the content is stored, and the roles and permissions you're assigned. let's talk about Power BI service licensing. Which type of license you need is going to be determined by where your content is stored, how you'll interact with that content, and if that content uses premium-like features. There are different kinds of Power BI licenses, which will be decided upon by the Power BI service administrators. In front of you are 3 examples of them. We have free, pro, premium per user. Premium per user and pro users will access to a Power BI premium capacity-based license, and these can create content within workspaces that are assigned to a premium capacity. Premium per user and pro users can then grant colleagues, including our free users, access to those premium workspaces. The other types of license is a per capacity-based license. And when you combine the features and capabilities of each type of per user license with the use of a premium per capacity, that is, where a pro, a premium per user, and a free license holder gains access to these additional features, as well as capabilities. We can share, collaborate, and work with enhanced data flows, deployment pipelines, and much more. I recommend you check out the documentation to see what you get per each license type. You should also think about upgrading your subscription should your needs not be currently met by your existing subscription. We explored licensing. Licenses give you control over your workspace in terms of its sizes, the semantic model sizes, as well as provide you additional features that you can have control over. It also tells you what kinds of features are available. And here's a bit of homework for you. If you had a premium per user subscription, how many users would you need before it becomes cheaper to go to a premium per capacity? I look forward to hearing from you and what results you come up with. Did you know that you can stream your real-time data directly into your dashboards using streaming analytics? Let's take a look at this video, which will demonstrate how you can connect to Power BI and/or Fabric and include your data within operational dashboards. In this data-centric world, it has become increasingly important to have the ability to view how data changes in real time. This ability is particularly important in the context of dashboards, and these are the canvases on which you can tell a story of the data. So the ability to show real-time streaming data on these dashboards can be very important to your organization. With Power BI's real-time streaming capabilities, you can stream data and update dashboards as soon as the data is logged. Streaming data can come from a variety of sources, including from social media, factory sensors, surface usage metrics, and other sources that contain a constant stream of data points. A common scenario are sensors that are sent from a stream from telemetry data into an IoT hub. And from this IoT hub, you can then use streaming analytics jobs to aggregate the data and then retrieve that into a Power BI, which is represented as a streaming semantic model where you can consume the information and build the pertinent visuals. So let's have a look at how we can implement it. For context, we're working with toll booth data. So data that captures when a car enters a toll booth based in the States. I'm in my streaming analytics environment, and I'm going to click my outputs and set up a Power BI variable. So when I do so, I can then give it an alias. So let's call this the connect to Power BI. And I will be selecting from my existing subscriptions, and these subscriptions is going to be referencing my Power BI workspace. So what I'm going to be doing is setting up a user token, but just note that you can also use managed identity, provide a name. So let's go for the toll booth, example, dataset, and I'm also going to come up with a name for it. So the toll booth, example, table. And then I will need to configure based on the authentication mode that I used. Because I'm using the author token, I will ask me to come up with my name. Right. I'm in. So now what I can do is save my credentials, save the output, and it's going to tell me if I did everything correctly. And what I can also do is prepare my query for data ingestion. So as you can see here, this connect to Power BI now exists in my output. And just a fun fact, I can also do this all inside of my query. I'm going to write in a specific query that will take a tumbling window based on my streaming data updated. Let me just double check that I have everything there. Wonderful, good. Right, so I'm now going to take an aggregated count of this because from an operational time point, I don't need every single car going through a toll booth. I only need to just keep a count per specific states. So when I'm ready, I'm going to save my query and run it inside of my overview. So this is what will be sent to my Power BI environment. Oh, I need to put it into my connect to Power BI. There we go. That's the right query to work with. So in my overview, I can now start my job. Wonderful. Okay, so the stream has successfully started, and what I'm going to do is navigate to my Power BI workspace. I set up a specific location for this data streaming, and what you will notice is that there is a data set that is now being generated in my Power BI window. When it comes to working with streaming analytics jobs and Power BI, just note you can only use a dashboard. So I'm going to create a new one, because you can never have enough of them. And normally what you're going to be working with is using streaming data for your operational data. And what I want to say here is that when it comes to working with analytical, where you want to play around with it in a little bit more detail or store the output, you should then store it into your dedicated SQL pool. So we're in this empty dashboard. It would contain additional charts for analysis to support those operational units and how they work. But for the time being, what we're going to do is just add a tile and select the custom streaming data that we have available. And when I click this, there's different approaches I can take. I can add an existing streaming data set that I have, or I can work with the data that comes into play. And by the way, for streaming analytics, everything is inbuilt and integrated from start to finish. And what you will see is the data sets are all coming from your streaming analytics job. So when I click this toll booth example and I hit next, it will tell me the different kinds of visualization types that I can play with. So what I can do is select the variable I want to work with. And I can do a little bit of processing of this. I can organize it in the way that makes sense for my team, as well as provide a title, total car count. And I can apply it. And all I have to do is if I wanted to change the output, I could edit an existing tile, or I can just keep adding. Now, what I want to point out for the second time around is that you have a fixed variety of visualization types. Again, this is an argument that if you wanted to use different visualizations, you should think about working with hybrid tables or data that is stored somewhere else. But let's just create a line chart just for the funsies of it. So let me select my window start as my axes and put in my count reading on my data set. And I can apply some form of aggregation, so per state, and pay attention to the values that are changing. So this should change every 30 seconds. Let me make these slightly bigger to make it a little bit more exciting. So just note that when it comes to working with streaming analytics, you need to think about the code that you put in. If I wanted to make changes to my code, I would have to stop my job, jump into my query, and then make the changes. One thing I would say is whilst you are testing or developing it, choose a smaller granularity in window, because otherwise, if you choose a day or a week, you're going to be waiting there for quite some time. So make sure you do your tests with smaller time intervals and then increase it out. And this also applies for the different kinds of columns you want to explore Include as much information as you want, because otherwise you should stop and play around. So that's a basic overview of Power BI and how you can use streaming analytics to incorporate your streaming data into Power BI. It's actually pretty fun to play around with, and you can create tables, some which you may never use, but some may be really vital to your organization for important tasks like logging and making smart decisions based on the latest up-to-date information. See what you can come up with and learn anytime, anywhere. I'll see you soon.